Proof that FTFE hates himself? Yeah, probably. How you all doing? I'm absolutely sure I'm punishing myself for crimes of a past life. Are you dancing? You better be dancing. Hello to all you awesome people in the chat. Charlie, Marak, Naz, Rachbot, Tao, Teppo. Lovely to see you here.
We're living on a disk, floating through space, with a tiny sun.
Hey, I'm FTFE, and welcome back to the channel that does to stupidity what Harry and Meghan have done to all of the bridges. Just all of them. They're burned. Like, carpet bombed those things. They just don't exist anymore. Wow. I hope you're all having a wonderful Monday and feeling in the festive mood as it's getting closer and closer to that celebration of capitalism we like to call Christmas. Of course, I've got the Christmas tree up and feeling festive. This is the 4th episode of me going into the lion's den and, you know, punishing myself for past crimes or something. And unfortunately, last week, the warnings of a level 7 facepalm protection were not sufficient, and I received no less than 4,012 lawsuits based on facial damages. So FTFE Enterprises are stopping all notifications about facepalm level protection and just saying, you watch this at your own, you know, discretion, because if you get hurt, it's your own fault. You know what's coming. Right, so I'm going to go into the Cosmology Tartaria 24/7 Discord and talk to some flat earthers. Thank you everyone for joining, and a super chat already from Icy Spin for 1.99 says lobotomy fund advance. Don't worry, doing what I do is a lobotomy. Let's go and see who's in there. Oh, quite a lot. I see Gleam. Let's join and say hello. Greetings, Cosmology Tartaria. How are we?
Hold on. We're not finished something yet. We just wait a second. Whether he actually has a lot of hair around his asshole or not, he's got hair everywhere. Do you know quite well hair's getting all up in that shit?
We're trying to figure out how Chewbacca wipes, Greg. I'm very sorry, but it has to be established.
Habits. More important, man. It's head and shoulders. I'm telling you, he does not wipe. He shampoos. I'm telling you.
Greg, we're having a debate on how Chewbacca shits and how does he wipe his ass.
Ah, right. Well, the thing is, what you don't realize, Chewbacca's species, they only shit once a year, and it's a whole ceremony, and they get their family around and shave each other's assholes first. So, you know, it's called the Great Shittening, and it's a horrible mess that day once a year on their planet.
Dude, best ad hoc explanation of Wookiee wiping I've ever seen. That's awesome.
It's called the Wookiee wiping.
The Wookiee wiping.
Shitting once a year, though? Really, guys? Maybe once a month at least. Come on, man.
All right, now that we've solved that.
Yeah, I go at least once every 5 days.
I've never seen him eat.
I mean, you know, there's
I've
going to be
never
one
seen him eat.
full-ass Chewbacca Wookiee out there that's going to
Oh, yeah.
eat a bunch of tacos and beer and hot sauce and give itself diarrhea the day before the Great Wipening.
Yeah. Could you imagine, like,
We
sitting in
didn't
that
even get
seat on the
into
Millennium
Wookiee
Falcon?
diarrhea, gentlemen. You were thinking the poop was going to be clean, solid, one chunk, or rabbit poop. No. We're talking liquid, open the faucet, all over the fur.
What you got to think is as well, that Millennium Falcon, it's not a new ship, it's old. So those seats, they're going to have like cracks in. There's going to be bits down the side, so it's just going to be saturated with like. Anyway, let's get to Flat Earth. Yeah,
That's why I said I wouldn't share a
Worst
pilot seat
flying
with him, man.
dumpster
There's
ever.
skid marks everywhere. Like there'd be
Are we-
little Wookiee turds stuck on everything.
Wait a minute. Are we talking like pre-colonoscopy type levels for boys? 'Cause this could be
people came for a
catastrophic.
Flat Earth debate. They're very confused.
Oh my god. Oh my god. Anyway, yeah. So Craig, this our newest addition here, Salty Sergeant. The newest, not new to Flat Earth, but new to our community. I don't think you know him, but I think you might be surprised.
Hello, Salty Sergeant. How are you? Hello.
Hey, what's up? Fight the Flat Earth, man. I admire your
Yeah,
content.
Craig is
Thank you
here.
very
I mean,
much.
it's all right. Clay is here too.
Man, I
Craig.
admire your content, dude. You're doing great stuff. Keep on fighting the Flat Earth.
Thank you, Elmo. I like it when Elmo talks to me.
Do you?
I like it when I watch your videos, man. They're so good.
I put a lot of
I
effort
think
into
Elmo
them.
tickles himself.
So I watch
Elmo
your
tickles
videos
himself to your videos.
and I eat like a fruit yogurt and it's like the best thing at the same time, you know.
FTFE
Elmo.
plus fruit yogurt equals good. Nice to know. Thank you.
Yes. Indeed, man.
This is honestly the strangest conversation that I've ever come into.
Yeah. And the fact that we had to let it roll out, like we couldn't not know. We couldn't.
Oh yeah, no, that's something you had to get to a resolution with, right?
I'm glad that you provided it though. It was
Yeah,
like
you
saying-
can leave it dripping. I mean, hanging.
I
Right.
may not agree with you on everything, Craig, but on the Wookiee wipening, I think you're spot on, buddy.
Yeah.
I agree on everything, man.
Leave it dripping. Gas.
I've got a question. If there's in here, I have to go, but how is it that a trip from Dallas to Korea
Oh my god.
and a trip from Dallas to Korea and a trip from Sydney to Johannesburg take the same amount of time?
Because the Earth is a globe.
Yeah.
There you have it. And gravity.
So-
Don't forget refraction. And those
And
flight time
refraction.
analysis. Yeah.
I mean, I'd have to look at the distances and stuff, but I assume they are what they're supposed to be. Anyway,
Don't forget about gravity. They
It's
got
just
gravity.
B-Ball's newest gotcha.
so today I wanted to talk to you guys about gravity. Nice segue there. And it's an interesting topic because
Hold
there's-
on, wait.
Why are you doing that?
1 second. Hold on a minute. Hold on.
Why?
You're telling me that you just came up in here and you want to talk to us about the thing that I just happened to mention?
Yes.
That's cool. Keep going.
Yeah. Jesus Christ, dude.
Gravity is an interesting thing to talk about because it is the most empirically verified part of science. There's so many measurements of it, so many verifications that it exists that it actually blows my mind that flat earthers try to argue gravity, and I honestly haven't heard a good argument against gravity. I could present countless measurements, Cavendish experiments, plumb bob experiments hanging off the side of mountains, Eddington experiment of 1919, measurements using tiny gold balls to measure a mass attraction between them.
Gin.
But nobody has managed to debunk anything or present any evidence that gravity can be replaced with something. So I would like the flat earthers in here tonight to basically argue to argue gravity with me and present some viable alternatives to gravity on the flat earth.
Yeah, exactly, man. I love gravity.
So, how are you going to locally demonstrate gravity?
How am I going to locally demonstrate gravity? What do you mean locally?
Yeah. Locally.
Define locally. I mean, locally
front of your
could be the stars near us within our galaxy.
No. In front of your face.
Oh, I could do
Locally.
a Cavendish experiment.
That's that low.
Now, let's not
The
appeal
Cavendish
to any.
experiment was only ever
let's-
done once and never duplicated, even with
let's
modern
That's
not
in
technology.
appeal.
right. Okay, I
Let's-
don't know.
let's-
Wait, hold on.
let's-
Somebody just said the Cavendish experiment was only done once and never duplicated.
Let's
It's
not
literally
appeal
done
to
all
your.
of the time.
Let's not appeal
I've
to
done-
your authorities.
Why are you
Let's
already talking all
appeal
over him,
to your
Kiwi, dude?
authorities.
Yeah,
Because
yeah,
I'm asking to not appeal to an authority.
Again,
which
I'm not
somebody
appealing to any
before
authorities.
me-
This is an experiment that I
Hold on a
performed
second.
myself to
For
verify the predictions of gravity.
Hold on a second.
Ah,
Please,
Kiwi.
just a minute here. For clarity, I asked the question first. The person that came in with Cavendish walked on me. So, before we appeal to the authority of Cavendish, I would like the question answered. In front of your face, please demonstrate gravity. Like, how would you do it? That's my question.
I would perform a Cavendish experiment. That's my answer.
I agree with
It's
you,
not
Craig, that
appealing.
many
It's not
people-
appealing. Hold on, let me talk. It's not appealing to any authority. It's me following the scientific method and matching a prediction that gravity gives us. The Cavendish experiment is something that is repeated all of the time. Every single first-year physics student in the world does it. I've done it myself. I've got many friends that have done it.
It is not
friends
an
on YouTube that
experiment.
have done it. It absolutely is
It's
an
not
experiment.
an experiment.
I don't
What,
know
they
why
spin it
somebody would say
9.8
it's not
meters
an
a
experiment when absolutely is an
time.
experiment.
I absolutely agree that many people do play with balls in sheds. It's a fact.
I didn't do it in a shed.
I did it in the
You can
garage.
play with balls wherever you want, bro. Not my business.
Well, you said it matches the prediction
Absolutely, yeah.
Right.
of 9.8 meters a second squared.
No, that's the acceleration on Earth due to gravity, not the predictions of gravity within a Cavendish
Gravity
type experiment. I can use a
is
Cavendish
an
experiment to
unproven theory.
hold on,
So
hold on,
Isaac
hold on, hold on.
Newton-
I can use a Cavendish experiment to demonstrate the prediction that gravity would create a force that is proportional to the product of two or more masses and inversely proportional to the square of the distance between them. I can use the Cavendish experiment to demonstrate that to be true, following the scientific method.
I mean, inversely, you mean two things that are held apart at like an equal distance. Is that what you're saying?
That's what it
Like
is.
12 inches apart.
What I said was it's a force that's proportional to the product of two masses and inversely proportional to
Yeah,
the
I
square
know,
of the
right.
distance
But, you
between
know,
them.
for normal people out there, what you're saying is like the same distance apart.
I'm saying that I can
No?
demonstrate that
Okay.
there is a force between two or more masses that is attractive, that matches the predictions of gravity. I can even use that apparent attraction to calculate the gravitational constant of the universe. And it works
So what
every
is-
time.
What is
How
the
does it
rate
work
at which
for water? Oh,
Sorry,
one
One at a
object attracts another? What's the measured rate that you measure that one object attracts another?
Well, the rate will be different depending on the force applied because of the masses and distances involved.
Well, how about just the force?
Well, again, the force is dependent on the size of the masses and the distances involved. So you will, what you do is you get two masses of certain sizes, and you say, well, if these masses are these sizes, this is m1 and m2 in the gravitational equation, right? The universal law gravitational equation. So you get two
Very good
masses,
example.
say 10 grams and 50 grams, right? And you place them a certain distance apart, and you see if there's an attraction between them, right? And then you move those masses closer together, and then you measure an attraction between them when they're closer together, and you see if there's a difference.
So in that equation, right? How would you apply that to something like a celestial body? Like how much measured force is the sun exerting on Earth right now? How would you figure that?
Well, you would get the mass of the sun and the mass of the Earth and the distance between them and plug it into the equation.
Right. So how would you get the mass of the sun or the mass of the Earth?
That's been measured. We've sent probes to the sun and stuff, so we know the size of the sun.
I've
we know
never
the
lent you my
composition of it.
galactic scale.
Cool story, Bo.
For the record, you can probe the sun.
Yeah, well, I personally didn't do it, but the NASA Polar Parker probe did.
The who? No, what it did?
So what's-
The NASA
Polar
Parker solar
Parker?
probe. Also, we can
The
bounce
NASA
radar
Parker
off the sun
solar-
and measure its size, and we know the composition
That
of it
was
due to
a tongue
spectroscopy,
twister.
so we can know what the mass of it is, and the mass of Earth is something that is also known. Plug that into the equation, calculate the attractive force. You can do that with any
Exactly.
masses in the universe. It's actually
Yes.
it's an interesting using the our knowledge of that equation and some of Kepler's planetary motion. we were actually able to discover a planet. That's how Neptune was discovered, because they were watching Uranus, and they knew what Uranus was, they knew how big it was, and that it was orbiting the sun. But they noticed that at a certain point in its orbit, it did something weird, which didn't match with what should be happening. And the only way that they could say that
how would they know what it was?
Let me finish.
How could they know what it was when they never went up there?
Let me finish
Can
before
you
you
know
jump
this?
in. Let me finish.
God, dude.
Thank you. So they noticed that it was doing something weird, and the only way that could be true, that could be happening, was if there was another massive body close to it, causing it to have perturbations in its orbit. So they applied some maths and looked where the maths said to look, and they found a planet. That is one of the most empirical verifications of gravity. We see something happening, we do some maths based on gravity, which tells us to look somewhere. We look somewhere, and we find what we were looking for. So,
or you could look and find it and then add it up. Yeah, 'cause I can see. I can see these things.
Still waiting for the measured mass of the sun that you plugged into the F equals GM1 M2.
Well, I don't know it off by heart, but the mass of the sun is something that is known and has been measured.
Well, I'll tell you, right, if you guesstimate the mass of Earth according to your model at like 5.98 times 10 to the 24 kilograms, and you put it in this equation, you end up with something like 685 newtons down. Like, that's your measurable 9.8 meters per second squared, right? So how would you do it for the sun? How would you get the mass of the sun and the mass of the Earth to put in these supposed equations that will return the amount of newtons that the sun exerts on Earth?
You just get the masses and you put them in the equation, and it tells you the the gravitational force.
If I have one unicorn and I add another unicorn, how many unicorns do I have?
Yeah, again, we know the mass of the sun because it's been measured.
Okay, does that make unicorns real though? That's all I'm saying.
Again, no one's talking about unicorns. We're talking about the sun, which is a physical thing that has been measured.
Yeah,
you're talking about the mass of the sun, which you're saying has been measured, but can't reproduce it or tell me the number, right?
Well, just because I don't know the number off the top of my head, that doesn't mean anything.
And we even that we measured the sun, and we had some kind of satellite right next in front of the sun and made cool pictures, man. Okay.
Yeah. Thanks, Elmo.
I just wanted to say that, man.
I'm not saying that you don't have the measurement for the mass of the sun. I'm saying that nobody has it, right? And the people that claim to it are presupposing many other variables, right?
No, then they don't presuppose anything. They use something like spectroscopy to literally measure the components of the sun, and we know the size of the sun. Then you can easily figure out the mass.
Spectroscopy. You're going to use that to determine the mass of the sun.
You can use it to determine the components of the sun.
Well, I'm going to defend him because we can use a colonoscopy to determine the size of Uranus. So it probably works just the same.
Yo.
That's fantastic. How
nice.
It literally like
thank
interprets.
you for joining in there. That was very helpful.
What spectroscopy actually does, according to my knowledge, right, is it measures and interprets the electromagnetic spectra from interaction between electromagnetic radiation. So you're looking at the light wavelength of the sun, and you tell me how much it weighs.
No, we can determine the components of the sun. We can determine the things coming from the sun with spectroscopy. We can use that to say that there's certain things coming from the sun that mean that the sun is made of something. So then we know the components of the sun, we know the size of the sun, we can figure out the mass of the sun. It's not hard. And when you plug it all into the equations, it all works perfectly. There is nothing wrong. When you put these numbers in, it matches what the heliocentric model says should happen. And we get orbits and stuff. It all works perfectly.
Like, because one unicorn plus two unicorns is definitely two unicorns.
No one's saying anything about unicorns. We're saying something about the sun, which has been physically measured.
But if you really look at it, right, spectroscopy is the precise study of color, right? So it takes the general visible light.
Color. It's the study of how electromagnetic radiation interacts with matter.
Keep reading.
Man, we have.
What am I reading off of?
We literally have
I did this video with Professor Dave.
Equations.
It's literally I wrote that script.
Exactly.
Professor Dave. No, that's not what I'm quoting. I'm Clay. Shut up. I'm reading off Wikipedia, right? So the spectroscopy is the precise study of color as generalized from visible light to all bands of electromagnetic spectrum. That's literally what I just said.
Yeah, it's the study of electromagnetic radiation interacting with matter. That's what the field of spectroscopy is. That's what you do with spectroscopy. You study how electromagnetic radiation interacts with matter.
Yes, but you're looking at visible light and you're judging the colors and you tell me how much the sun weighs. I'm just trying to get there.
That's a nice straw man. I'm saying we are using spectroscopy to find out the components of the sun. Once we know the components of the sun and we know the size of the sun, we know the mass of the sun.
Yeah, it's kind of like you have a cake.
And all the components of the sun also happen to be only found on Earth. None of them were mysterious off the periodic table of elements. It wasn't some foreign weird thing that the sun was burning on, creating all this energy. Thank God it just happened to fall in your already predetermined outcomes.
Are you talking about how the sun is nuclear fusion with hydrogen?
No, I'm talking about how would you look? It all happens to just all the components of the sun just happen to fall into what we've discovered on the Earth here.
No, I'm talking about like radiation, gamma rays, you know, all byproducts of nuclear radiation that we can measure coming from the sun.
I'm gonna withdraw with a Craigism. Ready? I don't know enough about that to know, but I know you're wrong, Craig.
What am I wrong about?
That was a solid one.
I'm just kidding. I'm making fun of your earlier thing with the
God, the Wixit thing is fucking hilarious. The studying that I've been doing, he's no idea what's going on.
I don't think he'll be here. But go ahead, Salty. I'm done.
So anyway, none of what happened there was any refutation of gravity. We can plug these numbers in, and it works perfectly. So I was asked, how do I demonstrate gravity? I can perform an experiment to show that gravity is a thing. We know that there's downward acceleration, and when you plug that acceleration on Earth into the formulas, it all works. I've not had anyone.
Well, of course it works. It's supposed to work.
I don't think anyone's debating if there's a downward acceleration, though.
Okay, so
I think both sides agree that there is a downward acceleration. I think the debate is on what causes that downward acceleration.
Absolutely.
So for you to strawman about what is the cause of that. For you to strawman us and not say there's a downward acceleration is kind of ridiculous.
No, I'm not strawmanning you because I've literally talked to flat earthers who deny that there's an acceleration. So it's not a strawman. The problem is that flat earthers say so many different things that it's pretty much impossible to strawman you.
You're making the argument that all things go down.
No, I'm not. I'm saying there's a downward acceleration on Earth that is approximately 9.8 meters per second squared. But of course, other forces can exist.
Pulling all things down at all times.
It does pull all things down at all times, yes. But other forces also can exist.
I just wanted to be clear.
Yeah.
Just before you move on, can I just make one point?
Hello, Gleam.
And hello, sir. How are you?
Not bad. Fucking cold. I don't know if anyone can see. I'm actually wearing what we call in Scotland a house coat because it's fucking freezing.
You know it. I've got my heating on full.
I ain't putting any heating on. How much that shit costs?
Yeah, that's it. I'm gonna have to wire it or something. I don't know. But anyway, the question is more. We agree. Let's agree gravity exists. Yeah. Before we move on to the next topic.
Well, I don't think that they're going to agree with you. That's the thing.
No, I'm agreeing with you. Just as me and you talking, I just need to ask a question. Much as you said, it works perfectly. Forget all the galaxy rotation and all that lot. We're just talking inside the solar system.
Yeah.
Wait there. Hang on. This is important. 2 seconds.
I am actually talking.
Oh, I didn't hear you talk. You just come in like a robot.
Let Gleam finish his point.
He's still roboting, I think. Go ahead.
Okay, the core thing, I'll cut to the point. Either way, obviously, gravity's premise is larger masses pull in smaller masses. Then why is it recorded by mainstream science that the moon is moving away from Earth and the Earth-Moon system is moving away from the sun? Citations in general.
It's usually to do with tangential velocities involved. And when you do the maths of how fast it's going, you can calculate that it should actually be moving away at a certain amount. But interestingly, when you look at the historical data of the position of the moon, it actually moves away and towards over time. It just so happens at the moment to be in a period of moving away from a recent study that I've read. But again, you can plug all the data into the numbers, and it shows that it should be moving away,
Craig,
as it says it does.
You can't say that. It's never going to get closer.
That's what we were thinking. Again, that is something that we've thought for a long time. But they've been actually looking at historical laser ranging measurements, and it's starting to show a pattern of possibly moving away and moving towards. But this is just a recent study that I've read. It's not, it's a kind of a new thing. They're looking at data.
Can't predict dark energy. That's all. It's just that expands all space.
So FTFE.
Over time, it will expand. Anyway, you can go on to the discussion of what is gravity now. Yeah, sorry, I was just putting in that point.
Cool. Thanks. So someone said FTFE there. Who was that?
I was going to bring up a different subject, but you just continue with this subject and bring it up later.
But I'm talking. What is the subject? Because I want to talk specifically about gravity today.
Yeah, I'm talking about gravity. Gravity. I'd like to.
Fuck me.
If it's possible.
Jin, did you want to have like a nice 1-on-1 back and forth with them, but then stop interrupting everyone else when they go, please?
Well, I'm trying to add my piece in before they move on.
Well, go ahead.
Again, we're not moving on. I'm talking about gravity.
So am I. Yes, I'd like to address gravity at the moment. Now, there was two gravities which you seem to be ignoring, and you're ignoring the fact that Sir Isaac Newton himself said that he didn't agree with the theory of mass attracting mass. He couldn't prove it. It was an absurd idea, and he did not want his name ascribed to that. You're ignoring that fact.
I'm not ignoring anything, and you're kind of incorrect.
Yes, you are.
All right, well, let me respond to that.
I'm not incorrect at all.
Let me respond to that thing first. Wait, one thing at a time. Let me respond to that thing first.
Hang on. Where
Jim, one thing at a time. One thing at a time. Let me respond to that first. Let me respond to that first. You're wrong. What Newton was actually, he said he didn't want to ascribe himself to was the fact that there was this apparent instantaneous transmission according to his maths.
That's not what he said. That's not
it was what he said.
It's not what's written down.
It is.
You need moderation. It is what he said. Fucking take a drink.
Yeah, Jin, it is what he said. He was talking specifically about the fact that his math implied that there was an instantaneous transmission of force, and that he didn't want himself ascribed to that because he didn't understand.
That's not what it was.
Yes, that's exactly what it was, Jin.
No,
you can keep saying it wasn't, but it actually was, and anybody can look this up and see that that's the case.
We're gonna have to meet him to continue, I guess, because this is.
But anyway, right, that's me responding to his first part. What was the second thing you said there, Jin?
Well, where do we observe mass attracting mass in the natural world?
Drop something towards the ground.
That's a begging the question fallacy that you're assuming.
I'm not. I'm sorry.
You haven't. You're not out. Okay.
The ground is the ground. Wait. Let me respond.
That is a begging the question.
Let me respond. Let me respond. Right. The ground is bigger than, say, this lighter in my hand. I let go of the lighter. It appears to be. It appears. Let me finish what I'm saying. Let me finish what I'm saying. Let me finish what I am saying. When I let go of this lighter, there is an attractive force making it go down towards the ground. We can see that happening.
Can I respond to that?
Maybe let me finish what I'm saying.
Scientific method.
That'd be wonderful, Yeah. So there's an attractive force. We can see that happening. Plus, we can do it in an experiment like the Cavendish experiment to see that mass attracts mass.
Again,
it's like
okay. So I just wanted to say real quick. The argument in contention is if there is this force that attracts mass to mass.
Yes.
Thank you.
So for you to then assert that it is what causes things to fall to the ground is begging the question. You can't assert. You cannot. You cannot.
I'm not making any assertions.
You screamed about me talking when you were talking.
I'm not making any assumptions or assertions. Mass acceleration force.
You screamed and cried about me talking while you were talking. So how about you shut your mouth for a second?
You finished what you were saying, and I'm responding.
No, I didn't. But
you literally you said something, and then I'm responding. That's kind of how this works. There's no assumptions. There's no assertions. Mass acceleration force. No assumptions. It's a thing that happens. But
so is this FTFT lectures or debates the server?
Well, you generally do need physics lessons, so I try to try to use it.
Retard. Is it FTFT insults or debates?
Well, I can do insulting as well if you like. That's always fun.
Well, that's what you've been doing, implying that I need some lessons from you.
Well, it's a fact. You don't understand physics. That's
No,
not an
it's a
insult. That's just a
Degrade the
fact.
conversation now. Degrade the conversation.
So anyway, what was the next point that you had? I responded to the first bit. What was the next point?
You are just insulting now.
Well,
let's not be so eager to be.
You're interrupting me and insulting me.
I'm waiting. I'm asking you directly to finish what you were saying.
All right, ready? This is how we're gonna do it. 1v1, right? And Noah, go ahead.
Yeah. Basically, mass attracting mass being the explanation for why things go down is the very argument in contention. So for you to assert that's the reason why is begging the question. Does not logically follow.
You finished?
I went on mute, so what do you think that means?
I was just double checking so you didn't cry like a baby. Right,
so
I
wasn't on mute last time.
No, you're talking again. That's fine. Right.
Well, you don't need to insult
you're
me.
still talking. He's still whining. There we go.
No, you're insulting.
No, he's still going.
You answer the question without being
he's still going. He wants me to respond, but he's still talking. It's amazing.
Well, I would like you to.
No, I'm literally about to respond, but he keeps opening his trap.
Respond, not insult.
Maybe if you shut the fuck up, I can respond.
Okay.
There we go. Good boy. Right. So that is the observation, right? And then we can use the scientific method to form a hypothesis and then make a prediction from that hypothesis and then do an experiment like the Cavendish experiment to verify that there is an attraction between mass. It all comes back to the fact that we can experimentally demonstrate that there is an attraction between mass. There is countless experiments to demonstrate this. The Schehelian experiment, Cavendish experiment, Cavendish type experiments using tiny, tiny, tiny gold balls, showing that there's an attraction on the micrometer scale. We can demonstrate that there is an attraction between masses. Therefore, when we do the maths of the mass of the Earth and the mass of this lighter and the acceleration of 9.8 meters per second squared, it matches the Fg equals gm1m2 over r squared prediction. So there we go. That's my response.
That's what you call scattergunning, right there.
No, it was a direct response.
It was a scattergun response.
It was direct response answering your question about how we can demonstrate that mass attracts mass. If you think it's scattergunning, that's not my problem that you can understand it.
Okay, Mr. Scattergun, how about we go one by one then, instead of you just scattergunning?
I didn't scattergun, I directly responded to you explaining how there's experiments and then cited some of the experiments. I don't think that's scattergunning, directly responding. Maybe you mean something different to the rest of us when you say scattergun.
One at a time, Mr. Scattergun.
Yeah, maybe you mean something different to the rest of us when you say scattergun.
One at a time, please.
Yeah, again, maybe you mean something different to the rest of us when you say scattergun.
Do you want to start with the Cavendish? You want to start with the Cavendish? Or
yeah, absolutely. I mean, I've already talked about the Cavendish, but we can go back to that 100%.
Or we can talk about the other one, but anything to keep you from scattergunning.
Yeah, but I mean, what would you like to talk about? As I'm here asking for flat earthers to
take your pick of how you proved gravity. Take your best one.
I have personally measured gravity using a Cavendish experiment.
So that's your favorite one.
That's the one that I've personally done that, so it's one that I like to go to. I've personally verified that it works. So yeah, I do like to do that.
You've personally verified that two balls move towards each other?
Yeah.
Congrats.
Matching the predictions of gravity.
Okay, and I predicted it was fairy farts.
And how would you test that?
I put two balls in a shed, and I measured the fairy fart force, pushing them together.
Yeah, okay, so talk me through the scientific method of how you reach that conclusion.
Well, I talked to some fairies. They gave me some observations.
We're going with the observation. What's the observation
I calculated how the force of a fairy fart on a ball, and then I put two balls in a room.
Being a dick doesn't refute the fact that this is an experiment.
You want to talk about being a dick. You want to talk about being a dick.
Yeah, you're being a dick to the whole of science right now.
You're being a dick. Sorry,
you're being a dick to the whole of science. That's not my problem.
You've been being a dick the whole time.
Yeah, okay, whatever, little baby.
That is your problem.
So again,
it is actually.
Saying fairy farts doesn't refute the fact that we know the
masses gravity doesn't refute the fact that fairy farts.
Saying fairy farts doesn't refute the fact that we can measure the masses of the balls and make a prediction of what the attraction should be. You can't do that by saying fairy farts.
Saying gravity doesn't refute the fact that we can measure the mass of the balls and measure their attraction.
You're just saying nonsense that doesn't refute anything. Are you saying that the balls don't have a
mass? Just like you. I'm just replacing what you're saying with fairy farts instead of gravity.
There is no fairy farts, but there is mass. Where did the fairy farts come in? Where did the fairy...
Exactly what you're saying. Instead of using gravity, I use the word fairy farts.
All right,
okay, you can call it whatever you want.
One of you needs to shut up.
Yeah,
somebody needs to do some listening.
Yeah,
right.
You can call it whatever you want. You can call it whatever the fuck you want. The fact is, it matches the predictions of gravity. You can call it fairy farts if you want. That doesn't stop it being an attraction between the masses.
And the observation was you pulling the observation was him pulling an object from the surface and then letting it go.
Any observation works.
Is that the reason? Is that the reason why Cheerios stick together in the middle of a bowl?
If you want to have a proper conversation, then have a proper conversation.
Hold on, Mr. Jane. I'm bringing up an actual point for this guy's Cavendish.
Hey,
I would like him to answer. Actually,
I didn't realize that it was the observation that was, in question. I thought it was the explanation to the observation that was in question, the space-time gravity curvature shit. Right? So what's going on here all of a sudden? It's like you went light years backwards for the whole entire flat Earth. They do know there's an acceleration. That's not in question. So it's the reason for the acceleration that's in question, dude.
I know, not me that's doing that. They're the ones that are keep questioning. Oh, right, okay, sorry, I thought you were. Apologies.
No, for sure, no. That's what I'm saying. Like, so it's like we can argue that it's not space-time curvature and give different explanations, but that's all we can really do with each other here. And nobody's going to prove it's space-time curvature. That's just, for me, that's ridiculous.
I mean, the Eddington experiment in 1919 is a pretty good demonstration of that.
Not of space-time curvature, it's not.
Exactly of space-time curvature. It matches the predictions of that 100%.
They assumed vacuum-free space, and they realize now that they're not looking through vacuum-free space. There's fucking all kinds of shit out there, gas, ionized gas, and everything. You're looking through these condensed gases and atmospheres of galaxies and galaxy clusters, and you're looking at chromatic aberration and shit, and you're saying, oh, well, look at that. That's fucking Einstein rings. Why are they always blue, then? Why is it the scattered light that you're seeing on the edges of the rings? Come on.
Because light travels.
Oh, because it's redshifted. Oh, yeah, well,
it matches the predictions. The fact is, it matches the predictions of space-time curvature in Einstein's equation. That's what we expect to see. It does not. It's not ad hocery. It's what we expect to see. Again, and it's matching what the scientific method tells you to do.
When you ruled out the fact that there was already a medium there, you ruled that out to expect to see this.
But the medium is a near vacuum.
I'm not finished. Have I been interrupting you this whole time, or is it someone else?
No, sorry, I was just responding to what you said. I'm sorry.
So let's don't do that. Right?
Yeah, sorry,
don't cut me out in the middle of my. There's definitely a medium. That's fucking where you're absolutely incorrect. There's every star has a medium. It's solar wind, and then all the way to its heliopause. Every single star, right? So, and that heliopause is actually very thick, dense plasmas as well, with electron densities that vary and all of this kind of stuff. But when you're looking at galaxy clusters, literally billions of stars in a galaxy, and then a cluster of those, you're obviously looking through atmospheric conditions in a big way over a longer distance. So much thinner, but much longer distance. Same exact fucking effect. That's why we can show the flat earthers the sugar water experiment as examples of refraction, because it's over a very short distance and we just condense the medium to make it more drastic over that short distance. The same thing applies if you reverse the idea and you get a longer distance with less medium, then you would have the same amount of refraction over this longer distance, because it's about the amount of contacts that or collisions the photon comes in play with this medium in this part. So less atoms to collide with, or molecules, then longer distance needed for this curvature. but you're still seeing it. And that's the problem. And they ruled out the idea that the dust and the plasma is actually redshift light, because they didn't even know that back then. And so they said, oh, this is the only thing it could be. Now that we're in the space age, we've clearly debunked all of that. Clearly. And we still keep adhering to this dogmatic theory, though, pretending like we don't have.
You have been going on for a while, dude.
Pretending like we don't have space. Yeah, because I'm just doing a thorough spanking before I go back to flipping the ribs.
I mean, okay, can I respond? Yeah. Space is a near vacuum. Even if you were to travel in a straight line for 1 trillion years, you wouldn't hit anything, ever. Because space is so big. Even the heliopods, the stars, would not get in the way of that beam of light coming from there to here. Space is still a near... I didn't interrupt you for the entire time you talked.
Well, I mean, the very beginning you did. So, I mean, touche.
I just literally let you talk for like 3.5 minutes, all right? Okay.
It was literally about 40 seconds.
Space is
I'm going to make a claim about space.
Space is a near perfect vacuum. Am I allowed to talk, or is everyone just going to talk over me?
Make your claims. Go ahead.
Okay. Space is a near perfect vacuum. We know this to be the case. So, the light coming to us from other stars isn't going to have passed through anything.
Claim number 3.
Really? So what is the
it's not just a claim that space is a near perfect vacuum. Space is a near perfect vacuum, and it matches it matches. Seeing the light from the Eddington experiment doing what it did matches the predictions of Einstein's space-time curvature. The amount that it moved, it matches the predictions. And there is nothing about modern space age that has debunked the Eddington experiment. There's never been
claim number 6.
Do you want to shut the fuck up, or?
No, go ahead. Keep making your claims. I'm just counting.
I'm talking, by the way.
Shane, do me a favor. Can you mute that guy? Thank you. Yeah, so it's not a claim that it perfectly matches the predictions of Einstein's space-time predictions with the Eddington experiment. That's exactly what we expected to see. And there is nothing about modern space age that has debunked the Eddington experiment.
Claim number 7.
Anyone want to?
Yeah. Okay. So are you done now? Because that's 7. I only talked about 3 things. And
I literally every time I speak, I'm getting interrupted. So I'm going to try and talk without people interrupting me. That would be wonderful.
It's not really an interruption so much as at the end of your sentence.
It literally is, because every time I speak, some fucking numpty goes claim.
I think you're whining at this point, though, because all he's doing is waiting for the end of your sentence.
Okay, so shut the fuck up, little baby.
Then he's going claim number 7.
Stop controlling.
What? Just being a dick. Stop being a dick. Right? Again.
It's more an insertion than an interruption.
So again, maybe I need to repeat myself, because it's not just claims, it is facts. It matches the predictions of what we say should happen. So just going, it could be something else. No, okay.
Does he get to repeat himself over and over again, or can I respond?
Yeah, because I'm going to repeat myself until I get to say it without being interrupted. Is that right?
You've already said it without.
No, I haven't said it, because every time I spoke, I was interrupted, and I'm going to say it without being interrupted, or I'm going to say it again.
Else anyway, dude.
I'm going to keep saying it until I say it without being interrupted.
I'm really tired of hearing this, so go ahead and finish it, please.
Thank you. Right, I'm going to say it from the beginning to the end, and if I get interrupted, I will start again. Right. What we saw with the Eddington experiment matches the predictions of Einstein's space-time curvature. It's what we should see. Nothing about the modern space age has debunked Okay, so what we saw with the Eddington experiment in 1919 matched the predictions exactly of Einstein's space-time curvature. 100%. It's what we should see, and it's what we did see. And nothing about the modern space age has debunked anything about that. That was a very positive claim that I would like evidence for.
All right, first of all, the bending of the light behind the star, is this what we're talking about?
Yes. That's the Eddington experiment of 1919.
First of all, the predictions for that were for it to happen several solar radii, or 2 solar radii away from the sun, that's when they predicted, because of the gravity well, that you would see the light bending, which is not where they saw the reflective light bending. What they did see, though, was in the densest part of the solar limb of the sun, where the most atmosphere is where they saw the star, which was supposed to be behind the sun, which is clear clearly in the densest part of the fucking solar atmosphere, which they claimed was a vacuum with no particles there. Even though they're looking straight through fucking particles. It's ridiculous. Now that we're in the space age, we know that's ridiculous. And that stupid fucking example still gets held up by idiots who decide that they're stuck in 100 years ago fucking science when we didn't have fucking, all the shit that we have now to know that that is a much more dense region of the sun. It's clearly ridiculous. And you're using that and saying it's exactly. You said this so many different times. I think you've hypnotized yourself into believing it when it's exactly not what was expected from the editing experiment. Excuse me.
Yeah, their original prediction actually was inaccurate.
Witsit.
So enjoy your red face.
Funny. No, it matches the predictions, and you can see all the papers to show it matches the predictions. And there's never been any. You keep saying that we know in the modern space age. That, what about the modern space age has debunked it? Nothing. There has never been a scientific anything to debunk what happened in the Eddington experiment.
Of course there is. It's just not being accepted by the dogmatic, theoretical, nonsensical, fucking, bureaucracy types that are holding these, ideas to be so true and not allowing for the paradigm to shift through their political bureaucracy.
Like what, for
because
instance?
Because Edward Dowdy, a NASA scientist, ex-NASA scientist, did a whole paper on, or maybe even several, but for one, he did a presentation speaking on this very issue where they confused the solar limb of the sun for this vacuum-free space during that Eddington experiment, and that refractionary properties, it's not just the plasma, but the electromagnetic fields themselves, or something about this. It's very detailed, but he goes into explaining why you're actually seeing these double layers, basically, of inside the solar limb. You're getting a reflection of the light from behind, as it's not quite like Snell's law, because it's more like looking at a mirror on the edge of the sun. From inside, when you're looking at it from that one angle, that's why you can only see it in the solar limb of the sun. It's never been observed outside of the solar limb of the sun, which is very confusing when the papers themselves depict that the bending should start a couple of solar radii away from the sun. That's outside of the solar limb of the sun, the plasma limb. And you really need to understand this. Imagine thinking that it was vacuum free and then learning 100 years later that it wasn't, but everybody still is agreeing that it's vacuum free because they're just agreeing that the observation was evidence for this thing that can actually be explained by a real mechanism that we do know about and we can reproduce. You can't reproduce your fucking gravity bending anything. You can't make something big enough for this force called gravity to be so strong that it bends any light. So you'll never have the privilege of doing an experiment on Earth to explain or describe what it is you're actually doing. So you can only use the theoretical hypothesis of your already fucking broken science, because you're still assuming it's vacuum free, even though you know it's not. And that's a big problem. That's called cognitive dissonance. So enjoy your red face.
Dissonance, not dissidence. That was the wrong word at the end there.
I've heard it both ways.
No, dissidence is not the right word.
I said dissonance.
No, you said dissidence, dude. You said cognitive dissonance.
Okay. Well, and still enjoy your red face.
So that was a lot of waffle about nothing. Mainly, the thing that's wrong there is that electromagnetic fields cannot bend light, because light doesn't have a charge.
No, they cannot. But with plasmas, they can. I don't know where you think you are, who it is you think you're talking to, but we're not just talking about an electromagnetic field all by itself in vacuum-free space now. We're talking about how the electromagnetic field aligns the plasma and causes a polarized situation in some cases too. And, you know, there's a lot more involved in just...
And no charge at all will ever affect
all by
light.
itself.
No
Nice straw
charge
man.
ever will affect light.
I don't know how... It's not a charge by itself. Again, it's a charge in a plasma.
So you're talking about the plasma, the light traveling through. So you're talking about the light traveling through the plasma itself.
That's correct.
Right. And your claim is that the refractive conditions of that plasma exactly match what we saw happen in the Eddington experiment. Is that right?
You know, a plasma is a partially ionized gas.
I just asked you a direct question.
No,
Could you please respond? I know what plasma is. I'm a nuclear engineer. I'm asking you a direct question. Are you claiming? Please let me ask. I'm asking a direct question. Can you please answer the direct question?
Flail about. Your question is nonsensical. It doesn't make any sense to the axiom I'm coming from, and I think you know that.
Can you please answer the direct question, right? You claimed
I think you know
that
very
the
well
refractive conditions of the plasma...
Conversation.
I'm literally trying to put forward,
Railroad.
Take forward this
everybody
conversation.
Listening, check this out. A plasma is a partially ionized gas, right?
Yeah, everyone knows what a plasma is. I'm asking you a question. Can you answer the question?
Plasma.
Well, you probably have to let him try to answer.
For the rest of the people, a lot of our own yeah, you're interrupting me, by the way, to try and make your question, and I'm trying.
Yeah, I
to
asked the question
something.
and you didn't answer it.
Because
you just want a yes or a no answer, and he might have more to say. That's all.
Something. Yeah, so you could cut me off from the explanation and not have the rest of the people hear what it is I'm about to convey. So a plasma is a partially ionized gas. Now, by definition, only 2% of that gas needs to actually be ionized for the gas to be considered a plasma, meaning 98% of that gas could be unionized, meaning you could be dealing with a chromatic aberration.
Maybe, I mean, this is a lot of could be's and maybes. But
well, at least we're using physical.
I'd like to clarify your position, right? Can I please clarify your position? Is your position that the light coming through the plasma has refracted to show us what the Eddington experiment claims is space-time bending? Is that your claim? Am I right?
Not exactly. There's more to it.
Could you please clarify your claim?
I can give you the presentation from Edward Dowdy where he goes through the entire
just
thing.
Clarify your claim for me. That
would clarify his point, because my point and his point can definitely be, confused.
I'm still waiting for you to clarify your point.
You said that aberration could be caused by the plasma.
What I'm saying, if you're trying to pin me down to one mechanism, I'm telling you there are several known mechanisms.
How is the plasma causing that movement of the star?
What I'm saying is there are several known mechanisms for light to be bent through a plasma. Okay, there are several known mechanisms, right? And we know now that this is a plasma, and we're by decree saying, nope, it's this unknown mechanism. It's gravity. It's something we could never verify. It's not the other two that we know exist in a laboratory and we can do and repeat constantly. I'm just not going to, by decree, claim which one of the two that are other two that are very possible that it is, because I don't know which one of the two that it is, or if it is even another. But we do know that there are at least two mechanisms for the light to be bending from behind the sun.
And what are those two mechanisms?
Within the plasma. One of them would be regular chromatic aberration. The second would be the electromagnetic mirroring from the plasma, creating a basic mirror effect on the inner shell of the plasma, so it would reflect the light from the sun.
So it's your claim
that we know two different mechanisms. Hey, shut up, dude.
Well, I'm trying. Don't tell me to shut up. I'm trying to clarify what is going on.
I'm talking, son.
Yeah, let me clarify. I need to clarify something before you continue. You're just monologuing without me allowing to kind of talk to you.
We're gonna have to mute you.
Sounds like what you wanted to do to me.
Well, you gotta also let him respond. FTFE. Let FTFE respond. He made a specific point. He's saying that he can test the variables he's saying could cause it, and it can actually be shown in a lab and demonstrated physically, as opposed to your claim of the bending and warping of space-time, which cannot.
Witsit, you actually just clarified what he said for me there. That was all I was asking him for. I wasn't trying to interrupt. I was literally just trying to get clarification of a point. Witsit, thank you. That was actually very helpful. Right. So yes, we know that mediums bend light, and refraction is a thing, but the claim that of these things being the cause of it needs to be mathematically backed up somehow. Is there maths to say that these things match what we saw with an observation?
Okay, so there is actually, right? Because that is why it's a known mechanism for bending of light in the laboratory, because they've observed it and they've repeated it.
So there's actually maths that say like this is the exact
wait a
amount,
minute,
right?
Hold on a second. Now, this is where you're trying to play a game, right? Since we could never go to the sun and test the sun to see exactly what the density is, you win. No. We've never been to the sun to.
The Parker probe has been to the sun.
We've been a million miles away from the sun, and NASA says we touched the sun. It's a lie.
That's within the star's
miles
corona.
away.
It's within the star's corona.
Yeah, in the star's corona, but not even close to the solar limb.
No one's taking a surface sample of the sun.
Yeah, you're a million miles away from that zone that you need to be in. That you're seeing that light from the bending of the light. So you're literally a million miles away from it, and then you're saying, since we and that means we don't know the actual density of that. We only have a theoretical density due to a theoretical model of what the sun is, using an ideal gas model, which is fucking ridiculous. So we already know that there are problems there. We know
it's
that
actually 3.9 million miles away.
It's all the materials that are found on here, and don't break or add to the periodic table of elements, lest we forget. They all just happen to be perfectly found here and explained. We know exactly what the sun is, boys. Down to the fucking molecule, we know what it is.
Yeah, hydrogen. That's a very common thing.
I know.
Shut up.
There we go, guys. Sorry, if you refresh, that's just sort that out on your end.
Yeah, I don't really know why we're talking about space when this is supposed to be a conversation about flat Earth. This isn't supposed to be
no, this is a conversation about gravity today.
Yeah, well, that's the
ask?
idea, though. It only exists in one model, so we can only talk about one model.
No, it exists in reality.
And talk
it's
about
measurable.
how it could exist on the other.
You guys all know space-time can't bend, right?
Have you got any evidence for that?
You have any evidence it does?
It makes no sense.
Yeah, the Eddington experiment.
You can't bend something that doesn't exist.
You got any evidence it doesn't exist? Because, evidence, like all of the stuff recently that's verifying Einstein's predictions verify everything about space-time.
You have evidence that space-time
Or the
exists.
fact that there's a medium in between.
That was like
Can't even
4 of you
verify
talking at
space.
once. Can't even verify space. I mean, Artemis did a bloody good job of that recently.
All right, shifting the burden of proof, a special case of argument ad ignoranum is the fallacy of putting the burden of proof on the person who denies or questions the assertion being made. The source of the fallacy is the assumption that something is true unless proven otherwise.
Fallacies have never debunked science, and they never will.
Okay, fallacies are about invalidating arguments. So
and they've never, ever, ever, in any time throughout all of history, debunked science, and they never will.
Well, that's another fallacy, which is called a straw man. What I'm saying
that
is,
wasn't a straw man. I'm just telling you that no fallacies have ever debunked science, and they never will.
So that was a straw man. I didn't claim fallacies
Again, not
debunk
a
science.
fallacy. I'm just telling you that nothing about any fallacy has ever debunked anything about science. Saying that that's a fallacy doesn't stop a fact being a fact.
Yeah, for you to respond as if my argument was that is called a fallacy. If it's not a straw man, then it's a red
more
herring
fallacies.
fallacy.
Brilliant. If that's all you got, fallacies, then that's fine.
Well, if you continue to do it, you're actually gaslighting. So we're
gaslighting now. Brilliant.
You say
so
if all I have is fallacies, but
Can you show me
this
an
is the
example
point, right? In debate,
bending outside of a math equation? Like, it seems like this is one of those things that only happens in mathematics and isn't demonstrable, the whole bendy space-time thing.
I mean, it is demonstrable. All of the Einstein's predictions are constantly coming true. I could cite hundreds and hundreds of papers of recent discoveries that verify things that Einstein had predicted, verifying things like space-time existing according to his equations. You'd have to literally debunk all of the studies and everything that's been verified that matches the predictions that Einstein said to say that space-time isn't real. You can't just go, well, give me evidence when all the evidence there exists, and to try and say that it doesn't, it's your job to try and debunk every single bit of evidence that we have.
Can I actually finish my point without using the word, please?
Well, there was like 4 people talking
Everyone quiet. Ready?
I thought Whitson
Ready?
had
You're still
finished.
talking. Nobody can hear anyone. Everyone's going fucking nuts. Guys, shut the... Just like literally, right? We'll have one person speak. Go.
I just want to finish my point, please.
Yeah,
I didn't specify the person. That's my bad.
Can we please let Whitsit finish his point? He was the one talking there. So Whitsit, please, go ahead.
So in debate, obviously fallacies are important, right? There's something called the fallacy, which is the assumption that because someone uses a fallacy in their argument, that means their conclusion is wrong, right? Just because someone is arguing fallaciously, it doesn't mean their conclusion is wrong, which means just because you're using fallacy doesn't mean that their space-time doesn't bend and warp, right? I'm not saying that. I'm saying that in order for you to propose an argument to support it, it can't be fallacious because that invalidates the argument. So if you're claiming that there is, it's quote-unquote science, or there's actual evidence that demonstrates it to be true, then you would have to put forth that. Or you would be shifting the burden of proof, which is what you were doing to Grimm, by saying, you know, well, do you have evidence that it's not? Because again, the shifting the burden of proof fallacy is the source of the fallacy being the assumption that something is true unless otherwise, or less proven otherwise. So I think that's kind of the boiled down part of it here. Do you have like direct evidence that space and time together as space-time exist and bends and warps?
I could present
better than that.
I could present lots and lots and lots of recent studies verifying Einstein's predictions about space-time. I don't have them particularly to hand right now, because honestly, I've been in and out of hospital this week getting stuff prepared for an amputation that's coming up. So I've been a little bit preoccupied with things. But I have
Sorry to hear that, man. That sucks.
I have a lot of citations, recent studies, constant verifications of Einstein's predictions around space-time. And if the predictions
stubbornly persistent.
Wait, let
him finish. I thought he was done.
Is that right? So, if we're going to look at how science works again, it's about verifying your predictions. And that's what science has been doing. They've been looking at all of the predictions that Einstein's been making, and they've been using science to verify those predictions. And I have lots and lots and lots of papers of recent verifications that I can give you, just not to hand at this point. Is that okay?
Okay, well, yeah, but all I'm trying to say is that when you were saying, do you have evidence it's not true, technically, before you substantiate it via specific evidence, that's a shifting the burden of proof fallacy.
Okay, right.
But
So
just so you know, the Eddington experiment, Einstein originally wrote a prediction in 1911, and it was incorrect. And then he updated it and changed it. So,
you can do that. You can do that in science. You can update your predictions.
I didn't say you couldn't do that.
We're not even
I wasn't claiming that you said that. I was just saying that some of that happens.
Okay, but my point is that you can't just basically assume that the actual medium that caused it was correct. Like the assumption of what it is causing it, that's correlation and causation being conflated, right? So, I mean, it's a pretty simple concept that you need to verify it. I have stubbornly persistent illusion. Stephen Hawking right here, and in his intro, he explains that as of now, right, we think that relativity in space-time is correct, but it could certainly be wrong. So I don't know why people pretend they know for a fact it's true or whatever. I mean, you could just absorb, well, it's just a theory, it could be wrong, we don't fully understand it, and it's...
Here's the thing, science never claims to be right.
Oh, man, if I'm not going to be next, then fuck this, bro, I'm serious.
Well, me and Witz are having a conversation right now, so...
No, you don't just get to wedge me out of my own conversation because you have a better time with Witz.
Witz and I are literally in the middle of a conversation, so if you could just be patient, we'll get back
All of us are.
Yeah, anyway, so... Witsit, really, check this out, man. All I have to do with him is to show another viable mechanism to receive the same observation. There you go, flailing around like a pigeon. Just chill out, man.
You interrupted the conversation.
The fox is at the fucking pigeonhole, and we're about to eat the fucking baby.
Why is this guy such a crybaby?
I know. So anyway, all I have to do, because he can say, I have thousands and thousands of experimental data where they show the same exact thing from the same exact fucking inferences or whatever, right? But that's okay. You can have that. But I also have one experiment on Earth that demonstrates another viable mechanism for that same result to happen with the same real materials that we do know exist, and we don't have to create any theoretical ideas or matter or anything at all, then we should go with the one that's in the laboratory being done over the one that's a theoretical idea that we aren't sure exists, even though you've repeated and interpreted your idea to be true to you over and over and over again with different experiments doing the same exact thing, interpreting it the same exact way and ruling out the other known effects. Sure, you're going to definitely have science behind you and a consensus if that's how the game is rigged, but you need to focus on what's really going on here. There is another viable mechanism to receive that same observation, and it isn't with theoretical matter.
Okay, so you're saying it's a viable mechanism, but is there maths to back that up that it would give the same results?
Of course there is. Why do you not know that plasma physics is a real thing, dude?
No. Specifically for the results of the Eddington experiment. Is there maths that your claim can specifically back up that the mechanisms you're proposing is the exact results given by the Eddington experiment?
Yes, absolutely. I told you, Edward Dowdy. Right? He's a scientist from NASA.
And the maths was exact, was it?
He did that by proposing certain plasma densities, yes.
Yeah, and of course, all the math and the mathematical predictions within relativity pre-existed special and general relativity. And typically within a theoretic framework. Typically within a theoretic framework. So to pretend that there's this exclusivity of predictive power within relativity mathematically is incorrect. Henry Poincaré put it together even before he did. I mean, most of the formulas were already there. So.
Right.
There's more than one way to skin a
all that
cat.
math
The idea
down to the 17th decimal point, it was so perfect, except for the James Webb Telescope blew it all apart. Oh well, I guess maybe galaxies formed much faster. I guess stars formed much faster. Yeah, that's what guys in the electric universe have been telling you for decades now, that stars and planets and shit formed a lot, in galaxies too, a lot faster electrically and not through gravitational means alone, if at all.
Also have a lecture from Stephen Hawking right here talking about Michelson-Morley and stuff like that. And he is explaining that quantum has shown us that, like Stephen Hawking's famous for, of course, Hawking radiation, helping to bridge the gap between relativity and quantum applied to a black hole, because, of course, it ends up predicting that the black hole would illuminate, which is contradictory to the idea that light cannot escape a black hole. But then they go on to explain that there's still major gaps, and that at best case scenario, relativity is drastically incomplete.
Hey, no, I will never disagree with the fact that science isn't complete, because science never claims to be complete. It's a, it's a constantly correcting thing. We get new data and new evidence, and we adjust our position because that's what science does. But there's no data specifically to make us adjust our position. The claim that the maths exactly matches what we saw in the Eddington experiment is something I'm going to have to look into as to how that maths works. And, I don't know if that's even the case. It's a claim that I would have to see backed up. But
it only matched once Einstein changed it because it didn't work. Okay, so I mean, it's a cool story to be like, relativity is so perfect, it made a perfect, precise prediction, and then bang, it was seen. That's not what happened, though. He had to change it. He changed the prediction of relativity because it didn't work. But either way, the point is that they said that you said we have no evidence that makes us have to change it, but what we do, right? Like we have cosmological and quantum evidence that shows us, again, best case scenario, relativity is drastically incomplete and could be completely wrong. Hence people proposing theories of everything and quantum fluid mediums.
That's brilliant. And actually, oh my God, did you see the recent paper about possible confirmation of quantum gravity?
No, I haven't, but
because
that's a good example of a replacement.
I would actually very much like to see you and Globebusters go over that. It's something very, very new, and it is is the closest that they're talking about to reconciling quantum with macro, as it were. I'm going to forward you that paper. And can you take that to Bob and Jaronism and cover it for me?
Okay, I'll read it. But of course, there are many versions of quantum gravity that have been proposed, most of which actually introduce a variable speed of light. So I don't know what this
this
one
is. This
but...
is the again, there is issues with it from what I've read, but it's the most complete possible combination of quantum gravity, and I would love to see flat earthers cover that. But okay,
I guess you clearly think it's some type of home run, but
no, not at all. No. It's an interesting paper. A lot of things I actually don't agree with in it, but I would like to see opinions from the other side, as it were, on that paper. Don't get me wrong.
Okay,
it's not a gotcha. I'm not trying to be like, haha, this proves you wrong or anything. It's just something that I genuinely think was interesting, and I would like to see from your side a response to it.
Okay, yeah,
cool.
Send it to me.
I DM'd you the link to the Dr. Dowdy presentation, or one of them, I guess.
Where did you put that? In the main chat?
I DM'd it to you, and I put it in the main chat.
You DM'd it to me. Okay, well, I will. Obviously, it's something that I've not seen before, and like I've said to Witsit, things I need to study and get back to you. Witsit, while you're here, I want to say thank you to you for something, because you are the first flat earther ever to make me learn new things. And I love doing that. I absolutely adore learning new things. And your talk about relativity has made me have to learn new things. So thank you very much for that. But it's not going to be good for you.
Yeah, let's
Since
pretend
that's
like you didn't.
it was backhanded, but
Thank you.
I'm waiting for
it's
you
not
to
going to be
catch
good
up.
for you.
Get something from me, dude.
Yeah, catch up is an interesting way of putting it. But no, genuinely, I like being challenged. That it's my favorite.
Can I ask you a question?
So,
FTFE?
Please do. Let's get this conversation back on track as to evidence for or replacements for gravity. So who am I talking to?
No. When it's my turn, I'd like to talk about it too.
Yeah.
Okay. Just a quick question. Why is math so important to you? Why are you hung up on the math?
So important to me? Because maths is a language of description of the universe. Maths is how
description.
We predict
so
things.
Math does not dictate the universe, my man.
I didn't say it dictates the universe. I said it describes the universe.
Describes.
Yeah.
Exactly. Awesome.
Yeah.
I love that answer. So English would be on par with that in some way. Logic.
Well, English doesn't have the ability to describe things in the way that maths does. Maths is a very specific language for describing very specific things.
Would you say it quantifies things?
Yeah, absolutely. That is kind of the job of maths, right? To give us quantifications and relevance to observations around us.
Yes, but in describing the universe, as you said, math could be completely off. I mean, it could be mathematically correct. Your equation could be correct, but when it ties to the universe and describing it, it could be like completely off. I mean, it's just a description. So why are you hung up on the math? I mean,
yeah,
I can say.
Okay, let me answer
that. I've done a debunk of math before, and it touches on that a lot.
Let me respond to that. Because maths is a way to verify things. It is to you make predictions, and you would use maths for that. You would describe what you see with maths. You can't even really do science without maths. Maths is important. Yeah, some maths might be wrong because we're finding new ways constantly to do maths that's more accurate or describes things in better ways. But that doesn't stop maths being useful for what it's for, right?
I never said it's not useful. I'm just saying it's descriptive. I agreed with you, right? It's descriptive. It does not explain, though, right? It's simply descriptive. And to use it as a measure of, like when you said predictive, the only thing that's predictive is what you predicted and explained or described in your equation. To confirm it by just observing it again within your explained or your described equation is logically fallacious in a sense. I mean, you just described something and then use the same description to confirm your observation. So it can't be. Let me just finish.
What you're saying? Sorry, I thought you finished. Sorry.
If I can finish, maybe you'll get it when I finish. Let's say I say 2 + 2 = 4, right?
In base 10,
I have 2 apples. You have 2 apples. 2 + 2. I'm describing this situation, right? I have 2 apples, you have 2 apples, 2 plus 2 equals 4, right?
Yeah.
Would you say you would use the math to confirm the situation? Like the math
the
confirms...
maths describes the situation. And
yes,
then you could then use maths at the end to confirm the situation by counting how many apples each of you have in your hand. You know, it's just a universal language. Like, you know, I don't want to get into a discussion about if aliens are real or not, but I think if aliens were real and we were to speak to them, the way that we would speak to them is with maths, because it would be something that's universal, right? 1 plus 1 is always going to be 2. You know, you get 2, you know, 1 and 1 of something, you put them together, it's always going to be 2. And it's just a way of describing the universe. And I think it's to take a phrase from the Big Bang Theory, maths allows you to look at the universe naked.
Yeah, I don't want to hog the mic, so I got my answer. Thank you.
Appreciate the conversation.
Hey, FTFE, would you like to publicly admit that when you were saying that it was 1/5000th the width of a human hair for the Lorentz contraction, that I was right and you were wrong?
Whitsit, I give a concession that I was wrong about that. Okay, absolutely. My argument as to my argument as to the why the maths wouldn't match up was wrong. My explanation was completely incomplete. You were right in a lot of the things you said. I'm not going to deny that, absolutely, which is, like I said, you've forced me to learn new things. I'm still telling you your conclusion is wrong, but that's something that I will be explaining later on. But yeah, absolutely. I'm not above admitting that I got something wrong, because I think that's the only way that you can learn and go forward. Oh shit, I was wrong about that. I better go and learn it, right? So yeah.
No, that's cool. I respect you admitting.
I was wrong, and you were right about that particular thing. There's a lot of intricacies that I want to get into, and once I've done a bit more studying, I would actually like to come back to you and have a full-on relativity debate specifically about these things. I'm still doing more studying because I think it's disrespectful to come into that debate not knowing about it, right? So yeah, I was wrong, and please take that concession. Absolutely.
Oh yeah. I just really the ridicule was pretty unfounded, because if you do the math, it matches perfectly, and you guys were both making fun of me for being stupid about that, but it's all good. I appreciate that you were honest, so it's all
I'm
good.
always going to admit when I'm wrong, because that's the only way to learn. It's as simple as that.
I think it's manly what you just did there, Craig. I'll doff my hat to you there straight away.
To say,
sorry, someone else started
like it's a given. You didn't CBR1.
That was a touching moment.
For quite a while.
So
just on the offside, while we're here,
could I not?
Just one
speak
concession.
now,
My God, that was so important. Thank you.
Sorry, I just want to go back and say one more thing to.
So no one.
Can you give me 1 sec? I just want to go back and say one more thing to Whitsit while I'm here. And Whitsit, I want to give you actually a heartfelt congratulations on the upcoming birth of your child. And I hope it is a glorious moment for you. Do you have any kids already, or is this your first?
That was my first. Someone just timed me out in your chat, dude. What a joke.
Right, please don't, guys. Please don't time for no reason. All right. If he's being rude or shit, yeah, but don't time him out for no reason, please.
Literally not. There's 47 insults personally to me, and all I'm doing is talking to DFE about the same subject we just talked about. But,
yeah, please.
The next thing that you're gonna have to admit, Craig, and this is admittedly relativity is kind of convoluted, right? But just so you know, and DFE doesn't know this yet either. It's the same thing that happened last time. You guys are, he's talking about how stupid I am and how I don't understand relativity in the chat and stuff. But he makes it very clear in his paper that Lorentz saved he saved the difficulty by saying that the compensation was just a sufficient amount, right? So it contracted just a sufficient amount to compensate for the time difference not detected. And then he says, we see also from the standpoint of relativity that this solution was the right one. So he point blank says that the contraction in the direction of motion being just sufficient to compensate for the difference in time was the right one according to relativity. It's just a different interpretation, of course, because relativity says there's no absolute frames of reference, and so you do not detect it. It doesn't contract for you in this reference frame. But if you were outside of the Earth, you would be able to see and even measure a physical length contraction. And that, of course, at relativistic speeds, it's a much more significant contraction. So if you're much slower than the speed of light, it's almost negligible. But of course, that's why it says it was exceedingly small, but they came up with an interference method that would be precise enough to detect it and should have been decisive. So, I mean, DFE still fighting that. I would encourage you not to really take notes from him again. He kind of left you out to dry in the debate where he didn't have to take it, but that is what I just said is pretty.
Like I said, relativity-wise, I am still. I'm speaking to a professor at Emory University as well as a bunch of other people to get my knowledge up to level so that I can have this conversation proper. I'm not going to argue relativity with you now because there's no point. I admit I don't know enough about it to have that conversation, and I think that's the best thing to say.
No, that's cool. I'm not even trying to debate about it. I'm just trying to give you a heads up.
But you know, I do want that to continue in the future, Witsit. You know, I want the relativity conversation to continue because I think it's actually a very important one. But I'm not going to do it until I know enough. It would be stupid.
Yeah, well, since we're all buddy-buddy right now and skipping off into the sunset, then maybe we can also cover this next thing. Can you kind of pump the brakes on the whole, like, borderline lying about me and what happened with the whole debate, like saying that I'm scared to debate Professor Dave and I'll only debate for money, because that's not really what happened. I told Professor Dave the entire time I would debate him for free, right? And then actually Bryant consistently reached out to me asking to give me money to do it on your platform. And then I talked to Dave myself after you said he would only do it on your platform, and he told me that he would do it on another platform. That wasn't true. And I'm like, okay, well, we can do it on a neutral platform for free. I mean, I didn't even mention money or say for free or anything. And then consistently for weeks, I ignored DFE as he was messaging me, offering me money. And then eventually he talked me into it to do it on your platform, and then reneged after I like paid off all kinds of debt, and now I have a baby on the way without. It doesn't matter. But the point is, like, can we just be honest about it? I never said I'm scared to debate Professor Dave, and I never said I won't debate him without money. I just said I'm not going to go on your channel, right? And then he tried to buy me into doing it. So can we like kind of not be dishonest about that, please?
Okay, I mean, from my point of view, it seemed like that. Okay, but you know, out of respect for you, I'll stop saying that you're lying and stuff. But let's just stop being stupid about this, and let's just do the debate. It doesn't matter where it is, if it's going to be on my channel or somewhere else. It's just about getting the debate done. And I promise you, a fair and honest platform that I'm not good. You know, my channel as a fair and honest platform that I won't be involved in the debate. And you know, you can stream it on your side and everything. You know, but it's kind of, you know, I just want to get that done because I think it's a great debate that could be held. And you know, you stream it on your side, I stream it on my side. Everyone's happy, you know. And I think the most important thing is that we both find a moderator that you and Dave would agree with. You know,
there are some primary problems. One is your channel is called Fight the Flat Earth. Secondly, so it's the opposite of a neutral platform, right? But in addition, you're going to get questions and answers section, right? And you're going to get a bunch of questions from the people in your chat right now who are the most toxic people I've ever seen, right? Like they're saying nothing but personal, hateful, toxic insults to me right now. What do you think their super chats are going to be? So you're going to make tons of money on super chats that are just bashing me, and then we're going to have a biased person reading off and commenting on questions that are bashing me and trying to set me up with gotchas. So that isn't fair. And, you know, it's going to be a huge debate, and we all know it. This is what's funny. The chat's saying it right now. You need to denounce the lie. Everyone in here knows I'm not afraid to debate Professor Dave, who's not a professor. You and MC Toon are way better debaters than Professor Dave, right? And I debate you guys, no problem. Everyone knows I'm not afraid to debate anyone about this conversation. So we can stop the narrative that I'm scared. I have evidence that I challenged him to a debate 3 years ago, okay?
Okay, so how about this? I promise I won't read out any negative super chats against you whilst you're there at all. All right, I won't put anything angry against you. I won't. Monday debates is out of the question for a lot of reasons, but
because
you know,
David's a pussy.
You could always do it here.
I'm giving you the promise that you know it will not be biased in any way. I will make sure that the super chats that I read out to you are just honest, genuine questions. I will ask the audience to be respectful. You know, I will do anything that you feel is appropriate to make this fair for you, Witsit. Because I'm not there trying to get like a gotcha. You know, I want to see this debate happen, And I think your side wants to see the debate happen, you know, and right, yeah, my channel's called FTFE, but that doesn't mean that it can't be a neutral place in specific circumstances, and I've shown that to be the case before. I've had debates on my channel where I've not been involved at all, and it's been completely done by an unbiased moderator, you know, and it's just been a genuine conversation between a flat earther and a globe earther that I'm not involved in. And I promise you that if you debate Professor Dave, I 100% promise you that it will be fair and unbiased, and I won't interrupt, and I would put some of my money aside in escrow to say that if I interrupt, then that money would go to you, you know, because I promise I want to show people that it can be a fair platform. You know, I can't force you to do it with it, of course I can. I'm offering you that 100% honest, fair platform. That's all.
Yeah, I'm not trying to take over the conversation and detract you guys and go back to the debating. I just wanted to clear the air. I'm probably not going to do it on your channel. I'm just being honest, it's out of principle. But we'll see how it goes. You know, he said he'd do it on a neutral platform. I think that's better for everyone. It is clearly the most in-demand debate, right? I've been trying to get it to happen for years. The only reason Dave's even like considered it, I'll give it to you, is because you reached out to him, but more so because so many of his own fans have been telling him to debate me. And
I did a lot of talking
it's
to him to convince him that you know that he should debate you, and you know, that's, I feel like I've put work in, which is why I want to be the host. You know, and that's it. And I understand that you have issues with my channel on, you know, you've got your reasons, but I'm telling you,
you are doing nothing but hating on flat earthers all the time, man. I mean,
yeah,
personally.
it's fun. I find it a lot of fun. But the thing is, here's the thing: it's not necessarily about flat earthers; it's about flat Earth.
No, but you make personal attack videos, right? So it's like, yeah, it's whatever, bro. I'm not trying to get into this with you. It's all good. I'm just telling you, probably won't out of principle. I told myself I wouldn't even debate you, and I did, right? I set up a formal debate in here, and I debated you when I really didn't want to, and you did the same thing then. You act like I was scared. So it's whatever. I mean, I don't care. Your chat's going to say I'm scared no matter what. Okay, but it seems like an honest person would say, it looks like Dave is afraid if he can only go to like a biased platform with a host and a moderator, as Globers originally proposed that MC Toon be the moderator. Are you kidding me? Right,
I mean,
it's
yeah,
like,
no,
we'll see how it
I
goes.
immediately admitted that wasn't the right thing. I mean, I would even suggest maybe, you know, both sides pick a moderator, like you bring Jeranism and Professor Dave bring someone on the Globe side, and they work together to moderate it or something. You know, whatever would be needed to make it fair. I understand you don't want to, and I'm not going to keep going on. I promise I'm not going to say things about you being scared or that, and you know, I'll move away from that. Right, the debate's there if you want it.
Okay.
But what as just a quick genuine aside before we move on. Congratulations on the birth of your child. Have a great Christmas with that. I've got 2 kids, and it's been the best thing that I've ever done. And I hope it brings you great joy.
What?
Well, thank you, man. Yeah, we are excited.
I'm confused
You guys can
with this
continue. I'm not
positive
trying to
interaction.
make it about me.
This is so weird. You guys are so nice to each other all of a sudden. I wasn't expecting.
It's my call.
I think it's how fucking cold it is in Scotland right now. It's just.
No, this is not on. I'm just making a call. Hi, Rumpush. Yep, Rumpush. You got me.
Oh no, is he here? Is he back? I feel like I done seen one.
Yo, I got something for FTFE.
Let's do it.
Okay, so you know that gravity and a globe are incompatible with each other, right?
That's a very bold claim. Could you please explain that?
Okay, so we're living on a ball, and we've got gravity, like, pulling everything down.
Mm-hmm.
And, like, wouldn't that, like, pull people off the bottom of the Earth?
Oh, I actually just face-palmed. Is this a genuine question?
Yeah, like,
I mean,
that's
like,
just
so.
it makes sense to
Not
me,
that I like
you know?
to use the fallacy thing, but that's a straw man of gravity and the globe. On the globe, gravity pulls down towards the center, not towards the south. South isn't down.
Okay, so wait, you're saying that... I know Globers say this, I'm just leading up to it. Like, Globers say that gravity pulls toward the Earth no matter where you are in relation to this mystical ball Earth. But how would gravity even know when to change direction and where? And if it was pulling in all these directions at once, wouldn't it cancel itself out and have like zero force? Like link your hands together and pull in opposite directions. Like no motion occurs. It would be like that.
It's pulling towards the center. From every point, it pulls towards the center.
Yeah, but wouldn't that cancel out? It's pulling in opposite directions at once.
Right. So if you were at the center of the Earth, right, you would be weightless because gravity would be pulling you in every direction exactly the same, right? But if you're on the outside of the ball, you're just being pulled directly towards the center at every point.
But wouldn't the pulling in opposite directions just in general, wouldn't that make it so gravity from one side was pushing you up if you were on another side, and it would, like, counter itself out?
Well, no, because it's towards the center. You do know what center
You know what
is, right?
magnet is?
I mean, the center of the Earth works on, like, a flat Earth model, but it doesn't really work on a globe because, like I said, the Earth would basically implode on itself.
Could you provide a reason for that, please?
Well, gravity. This would be like that part where you cut to the meme of the guy going, "Gravity, you fucking retard." It would be like that.
Desert file. You gotta love it.
Implode the Earth.
Yo, dude, are you actually a glober trying to pretend to be a flat earther?
He sounds like a flat earther.
I am getting big Poe vibes here.
I mean, his name is Shitpost Malone. We've never seen him.
Oh, that's Shitpost Malone. No, yeah, he's a Poe.
That's stupid, man. That's the silliest thing I've ever heard.
Yeah, just trying to make flat Earth look stupid, but
yeah.
I mean, if you want to talk about what's wrong with gravity, it's very simple, man. It's very simple. It's like we have the theory of relativity, and only special relativity, which is straight lines, right, can be applied to the quantum scale, and we can't combine quantum and the cosmological scales, and then the cosmological prediction based on the distribution of mass with the predictions of relativity are wrong. Relativity demands there be much more matter or mass, and so as it stands right now, it's not even viable, like even mathematically, without some like additional undefined variables to kind of keep it together. So it's like every time I talk to like people in these fields, they admit like, yeah, relativity was ingenious and it was really good. It's really groundbreaking and it seems to have some truth to it. But we all kind of know that it isn't actually the answer. So,
I mean, gravity works. On a local scale, gravity explains everything that we observe.
Relativity wasn't needed for the local scale. I mean,
no. I'm not necessarily talking about relativity when I'm talking about gravity. I'm just talking about the observations that we have. You can on Earth, if we're using gravity, we don't use relativistic equations. We're using Newtonian equations for gravity because that works at a local scale. If you're trying to calculate the load bearing properties of a bridge, you wouldn't use relativity, you would use Newtonian mechanics. We don't need to use relativity to describe gravity and show that it works on a local scale, on a solar system scale.
Okay, and so of course, and on a basic level, like calculative presupposition doesn't actually make something true. Like I have an equation to explain how Superman flies, right? I think there are some fundamental conceptual issues with it even. So like relativity basically says it can't be tested. Like it says there's length contraction, but you can't measure. There's time dilation, but you can't measure it with inside the same frame of reference. And in addition, it's basically attributing physical properties to conceptual abstractions, where Einstein says, well, there must exist an ether in the sense that space-time must have physical properties, but it can't be mechanical or have motion applied to it. And I misspoke when I said that when I concluded the non-existence of ether, I should have rather said the non-existence of an ether drift and blah, blah, blah. And so it's like this physical properties attributed to conceptual abstractions, right? I mean, one of which is a privation. Tesla critiqued this right when it came out. In addition, he also said that, if there's equal and opposite reaction occurring to my simple mind, the bending and warping or the curvature of space-time would straighten out due to the equal and opposite reaction in all directions. There are many conceptual problems with it. You can't apply it to a black hole because it can't be applied to singularity. we had to come up with this theoretical thing to save it over and over and over. Hawking radiation, black or dark energy, dark matter. There's a bunch of things that show us that it's wrong, and it can't be applied at all on the quantum scale. So,
not necessarily.
Yeah, I mean, if you just want to claim the idea of the effect without
Sorry,
supporting the cause claim, I guess you can say it works. But
I mean, I don't disagree with everything you've said there. There's things that we don't understand, but that doesn't make it wrong. It just means that there's gaps in our knowledge, and that's not an issue. But, call it whatever you want. There is an attractive force between all masses that's proportional to the product of two or more masses and inversely proportional to the square of the distance between them. That's something that is verifiable. We can show that to be the case, and you can call it what you want or explain it however you want, but that exists.
If that's what you want to think, yeah, I mean, mass attracting mass is
the question.
I've verified it exists.
It's antiquated, right? Like gravity's not even considered to be an intrinsic property of matter anymore. It's been disproven in many ways.
Absolutely, but like I said, we still use Newtonian mechanics in this world. Any engineering in this world is done using Newtonian mechanics. Whenever gravity is in an equation in engineering, it's Newtonian. We don't use relativistic equations because we don't need it to be that accurate or that complicated. You could do all the calculations with relativity, but it would just be infinitely more complicated. Yes, Newtonian explanations are hundreds of years old, but it doesn't stop them being used every day accurately to show that it's true.
Newton doesn't have explanations. This is a big misconception from Ballers. He didn't propose an explanation.
I didn't say there's an explanation. I'm
you
just
said Newton's
about
Newtonian explanations.
Yeah, Newtonian explanations of mechanics in general. And when I say Newtonian explanation, I mean like the law of gravity being an explanation of the force properties. Not that
you want to know the ironic
Newton
part,
never
Craig.
had a theory. Newton never had he just made an observation, right? His observation was that mass attracts mass with this proportions. He never said, "Oh, I think it happens because of this," and that's why he was, he was very much like, "Well, I don't like some of the things that my math implies," right? He didn't like that it implied that there was this instant, transmission of force, but it doesn't stop that being accurate enough for us, to test and see that it is the case with the accuracy that we need on a local level.
Yeah, we can use like kinematic equations to get downward acceleration, which is what we're using in engineering, right? Like you can use a kinematic equation with height, time, and initial velocity, and these are verifiable factors and variables. So I mean, actually, it would be more useful because it could be verified, as opposed to like Newtonian application where we integrate an assumed R value in the masses, right? Like you can actually get that downward acceleration in many ways.
There's no assumed R value. The R is just the distance between the masses,
and the center of the Earth, yeah. So that's an assumed R value. But
can we just be clear though for a second? Can I just clarify? Is it not, when you say, "Oh, we use it in technology all the time," yada yada, is that not basically just any such thing's rate at which it has that downward acceleration? So
no, it's not just the acceleration. It's the actual. You can use Newton's law of gravitational acceleration to actually calculate forces applied to say, right, well, this is going to take this much. And we're going to need it to
begging
be
the question
this
fallacy again. Look,
again, it's not begging the question fallacy. It's something that's used in reality. When you are building a bridge, you will use Newton's law of gravitational acceleration.
Hasn't been proven though. Gravity has not been proven. You haven't proven gravity.
Science
so it's
doesn't
an assumption.
Prove things. I've measured gravity. I've shown that gravity is a thing. No, science doesn't prove things.
Gravity, sir.
Yeah, all the experiments.
The possibility that gravity does these things.
I've talked about all the evidence of gravity. There's constant measurements of gravity.
But it still is just only a possibility among many other explanations for this thing.
Well, what is the other explanations? Let's talk about the Cavendish experiment specifically. What is the other explanations for the measured attractive force between the masses?
What I'm trying to say overall is that I can't cite experiments and all that. I'm not What I'm saying is that there is more than one way to skin a cat, and just because one explanation is accurate doesn't mean that another explanation isn't also accurate in a certain in its own right.
Absolutely, that's why you have variables. I was just wondering, can we let PhD Tony in, please?
Current explanation is not
1 plus
accurate.
3
though.
equals
The
4,
current
but 2 plus 2
explanation
is
not
4.
accurate.
Both of them are right and the same.
Well, oftentimes Cavendish doesn't give. So the thing about Cavendish that people love to overlook is that it's like super sensitive, and oftentimes you don't get the proper result. But it's set up in such a way as to be unfalsifiable, similar to like everything the globe does. So like if you get a reading that's not expected or doesn't match the prediction, it's thrown out with assumed user error because it's such a delicate,
Yeah, it's a
precise.
bad experiment. Then it's not an accurate experiment.
When I did it, you know, it worked, and it just, you know, yeah, they're difficult to do because there's such minute forces involved. But when you do it properly, it works. Of course, you can't say a bad experiment given bad results debunks anything. That's kind of ridiculous. It's like with Mitchell from Australia showing a pendulum not moving because the exhibit's broken and claiming that it shows the Earth doesn't rotate. No, a broken experiment or a not working experiment doesn't show anything. Every
No, that's
time
not
the
what I'm
experiment's
saying.
done
I'm saying
properly,
that it's cherry picking. It's like it's a prestige example of cherry picking. Like also,
it's not
sometimes whenever you
cherry-picking.
do see it move the direction it's supposed to, it isn't the right amount. And then what people say
It's
is, oh,
always
it's
the right
close enough. Right? Because it's such a small change. Like if you go back to when Cavendish did it, he had to go super far away and use a telescope to look at it, and it was barely any change. He didn't even account for electrostatics or anything like that. And then you have all kinds of problems. Even if there is a slight movement, even if there is a consistent slight movement, which it is actually not very accurate and consistent, but even if we claim that it is, right, you can't actually eliminate the variable of the electric and magnetic constant. You could put it in a vacuum chamber and ground it inside a Faraday cage, and it's still there. What?
You can change the material.
But it's all going to be intrinsically electrostatic. Like there's no exception.
Materials have different electrostatic properties, so you would have different forces involved if there is different materials, and you don't. Regardless of the material, the mass is what's important. It could be wood, it could be glass, it could be metal. It doesn't matter. You still get the same results.
Chickens and turkeys?
No, actually, you don't. See, this is what I'm saying. I just
You do.
explained
I've
you
done
actually
it,
don't.
personally.
Yeah, and I know for a fact that you didn't take incredibly precise measurements to show that it matched the exact amount exactly as gravity predicted, and it happened over and over.
Degree.
You didn't do that.
I did. That's how I passed my physics degree.
Okay, drop the experiment with all the precise measurements.
I mean, I didn't.
Because I've talked to many physicists that say it's actually almost impossible to get it to consistently work.
Well,
so you're saying now that this works amazing.
Blue Marble Science and BM Furball both built one and showed the entire process on YouTube and got it exactly right. Even
Blue Marble Science told me that the first few times he did it, it didn't work. So
because
the point is, he literally told me that
once it was
himself.
set up right, it worked, and now it's actually in a university as a teaching instrument because it's so accurate and works every time. Once it's set up
Let me just address
it works.
I'm about to eat and I'll fall back. So let me just address the one part real fast. Okay, it's like the point is that it doesn't matter about the materials, right? Because when you ground it and you try to eliminate electrostatics, you get it to a very, very small degree, right? And electrostatics is overall weak. So it's like the amount of movement isn't going to be much. It doesn't really matter. And the primary thing seemingly transferring with electrostatic induction is the background itself, like the electrostatic, like the electric currents, right? That's always there. The magnetic and electric constant. This would be a very small transference of charge to the objects. And so it wouldn't be a huge interaction, nor would it change drastically based on anything like the composition of matter, because you're grounding it all out if you're doing it properly, right? So like that's the point. It's Faraday cages don't attain zero, but they get very close. And then when you ground it with, like you're trying to control for that variable, but you can't fully eliminate it. Well, just the smallest little bit is still going to affect it. And on the smallest scale, it's 10 to the 39th power stronger than gravity. So it's like
Only on the,
you can't fully control the variable that could cause it to happen, and you throw out a lot of the results that don't match it. And if you don't count for electrostatics, what happens? It changes a lot more. It changes a lot more violently. So.
But
I mean,
again, electrostatics would be different depending on the material. We can't say that that's not the case. The forces applied by any electrostatics will be different if the materials involved are different.
So if you ground wood and ground steel, what's the difference in charge?
Well, the materials are still going to have a different charge, right? They're going to react to
but if you
electromagnetic.
ground them, what's the difference?
They're going to react to electromagnetic things differently. Like you can ground a metal, it's still going to react to magnetic field, but wood will not, right?
Well, it does react, but not as much.
Yeah.
So like I would say that a good experiment would be very precise, consistent measurements of different materials. That would be a good thing to do, and you'll claim it's been done. But
that's what my group did in my physics degree. I did wood. We actually had someone working in the freezer of the cafeteria trying to do it with a ball of ice. We had different metals involved. There was one that was plastic filled with sand.
With the turkey and chicken.
So mine
was organic material. It's all proportional to mass, regardless of the type of material. That's the point here, is that you can change the properties and the type of material that you're using. What the effect is proportional to the amount of mass. And then
again, you don't actually get the consistent, precise value of the prediction. That's just objective.
I do.
You guys
you
do.
I'm telling you, you do. I've done it myself.
And then when
it works
it's kind
100%
of close,
of the time. When you do the experiment properly, it works 100% of the time.
No,
right.
So
I streamed mine.
I streamed mine every single time perfectly.
Yeah, I streamed mine for 40 hours with it using different materials, and then there was one iteration doing it for 30 hours nonstop, and I had 6 different manipulations within that. And it happened consistently every single time.
How much did it move?
How much? I think the radius. I was using a light to bounce off a mirror of the torsion wire, and the radius of that was about 10 feet, and the movement was about 8 inches. So I think it's only like 0.4 of a degree or something. I think that's what it comes out to.
About 8 inches. So it was the same exact amount every time?
Yeah, using the same amount of mass, yeah.
It was really, so you have very precise measurements when you say about 8 inches. So what was the prediction of gravity? What should it have been?
No. So this was to appease Chemo and his dumbass claims of it not existing. The question I was answering was, does it?
Are we backtracking?
The question I was answering was, the question you're doing it right now. The question I was answering was, does it exist? I took rudimentary measurements, but I didn't have a quantified prediction, because the question I was answering wasn't by how much. The question was, does it exist? Right?
Okay, so this is back to my original point, because I'm about to start eating, and you guys can talk now, but the only point is that you guys pretend it works so perfect and amazing, and it just verifies gravity, but every time you ask, okay, well, what was the precise prediction of gravity? What was the precise measurements? And it consistently match exactly what the predictions are. They never even account for that. So it's just it's a joke to invoke it, but you can do whatever you want to if it makes you happy to believe in that.
Yo, I got an idea. How about for your...
Yeah, I mean, that's literally what you do. You make a prediction when you're doing your physics degree. You make a prediction based on the masses that you have of what the movement should be, and then you see what it is, and it matches. Every single person in our group managed to do it, apart from the guy with the ice because he couldn't keep the ball frozen. It worked. The masses, as long as you know what the masses are, you can predict the exact amount of movement, and it works as long as the experiment's set up properly.
I think that the topic for your BioDuo versus Witsit on this Saturday should be BioDuo's experiment. What do you guys think?
That seems pretty awesome.
I didn't know we agreed.
No, I gave my 5 topics, and I gave them very specifically. I want both sides. For me to participate in a debate, I want both sides to have a positive argument to something. That's where I'll debate.
It sounds like you're backing out already, BioDuo.
My positive argument is that everything that exists is electrostatic, and on the smallest scale, it's 10 to the 39th power stronger than gravity's even claimed to be.
Cool. I've got 5 topics that I DM'd you, and I think Shane has provided a couple times. But I'm open to those 5.
I'll read them, but I don't. I'm not like the ballers seem to have this diluted opinion that they just sit at home, and there's like 20 of them that do this, and they come up with a new what they think's a home run gotcha argument for Witsit. And then every time I come in Discord, they're like, "Hey, I got a new argument. I want you to have to answer. You have to answer. These are what you have to debate. You have to debate me at this time and about this time."
That's not what happened.
That's not how it works, man. That's not how it works. If you show your face and your name and you have some credentials and you want to jump on camera.
I know, that's great. So 3DP randomly created a debate event between me and you, because I think he randomly asked, and we were both like, "Yeah, that's cool. We'll decide a format and a topic." but he randomly created the event, and now it's like a perpetual, never-ending situation in which a date will be made. Oh, Whitson and Baldo are gonna debate, and then once that date passes, then it's created again. We're just in this perpetual motion of.
It's never passed. It only got moved once because I asked you about it, right? But it's very specific. There's very specific details in it. You both already went over it, so I don't know what you're talking.
But anyway,
I just want to say one more thing. So do you guys agree Faraday cages don't attain zero?
No, you're right. The Faraday cages cannot block out 100% of electromagnetic signals. They block out the majority of it.
Okay, thank you.
There's actually a very good equation. There's an excellent equation. I can't remember off the top of my head, but there's an equation that relates the like the mesh properties of the material to the amount of electromagnetic properties that come through. I'll have to forward you the actual equations that you can find out how effective a Faraday cage is going to be. But Whitser is right when he says that Faraday cages do not block 100%. It's as far as I'm aware, that's not something that's possible.
May I speak?
Hey, PhD Tony, how you doing?
I'm well, thank you. How are you?
I'm good. Thank you very much for asking. I'm glad you're here because you are someone that actually works in the field and uses gravity. So I think you're an excellent person for this discussion.
So there are, it took me one afternoon on YouTube to find 24 published peer-reviewed articles that have verified Newton's laws of gravitation and do not rely on the same methodology as the Cavendish experiment. On a daily basis, we use gravimeters to survey for underground mass distributions using Newton's law of gravity. So the claim that there's some, all of this nitpicking around the Cavendish experiment is irrelevant. We've got much better experiments. We've got much more precise equipment, and we use it on an industrial level. If you look at a map of the globe, you'll see maps of the ocean floor. The way we obtain those is by gravimetric surveys. Because rocks are heavier than water, we can detect where the rock is and where the water is deeper. That's how those maps are largely constructed. We have some acoustic surveys of the ocean floor, but not much. It's mostly gravimetric data. So this claim that gravity is this theory, it doesn't work, it's not practical, it's nonsense. We use gravity every day, and every time we get an accurate result, we confirm the theory. We use gravimetric satellites to track flood events on Earth's surface because we can detect the gravitational signal of the water on Earth's surface at the level of the satellites. So, Whitsitt can assert that there's some finicky problem with Cavendish, but that's simply not true. If you have any familiarity with gravimetric surveying, gravimetric mineral exploration, seafloor mapping, we even use gravimetry to navigate submarines passively around ocean floor obstructions. So we use gravity all the time, and if Newton's law of gravity were incorrect, none of this would be possible. We would be getting the wrong result. We wouldn't be finding minerals. We would be crashing our submarines into the ocean floor all the time, and we would not be able to accurately map the ocean floor. In reality, we can do all of these things because Newton's law of gravity is correct and accurate and verified on a daily basis.
Well, it sounds good. Of course, your paradigm disagrees with you fundamentally that Newton's laws of gravity are correct. That is not true. The conceptual backing for Newtonian gravity is admittedly not viable or accurate in your own paradigm. Quantum scale gets even worse for your assumptions of gravity. You just monologued, and now you're immediately interrupted.
Okay, as soon as
you have a PhD, they didn't teach you how to debate.
As soon as you lie, this is not a debate. I am educating you. You just lied.
No, it's a debate, Tony. Settle down, bro.
When you say,
settle down.
Now it's his turn to monologue again. This guy.
Right, holy fuck.
Made a false assertion. Okay, so he can monologue for 5 minutes, but his entire argument I'm going to come back to. You
Okay,
lied.
so shut up and let him fucking talk, guy. Holy.
Okay, but it's a waste of time because he lied at the very start.
I know, because
Thanks, Doug.
Globe in my textbook says this.
Yeah, so quantum has shown that, for one, like even like Newton's laws are questionable, but you can deny that if you want to. I don't really care. Anyway,
Can you cite that? Can
yes,
you cite
actually, I can.
Where?
Can you stop interrupting?
Where? Please provide the citation because I can provide citations
Fuck this
that are
kid,
calculated
man.
down to 75 micrometers.
I can show many different references that show like well-accredited academic sources that talk about how quantum is in conflict with Newtonian laws, and I'll drop them for you in a second.
Yeah, real quick though, just like FTFE has the top left thing, flat earthers need the most triggered fucking glober, and that is by far Tony, and he's setting the bar for future fucking globers.
Let's not.
Triggered little child, but he's
how do
highly
you explain
educated.
the fact
Oh.
that you can use Newton's laws to get accurate results? Then.
Yeah, it was talking
I'll
about
try to
quantum
explain it to you
effects.
guys again, but you keep interrupting. So, like, yeah, so all you're talking about is we use downward acceleration, agreed upon average of a downward acceleration, which we give a constant value. We use that for many things. Now, he's basically trying to then say also based on like mineral composition, based on the density and the mass distribution and stuff like that underneath the Earth and blah, blah, blah. These have actually been shown to be decently accurate at times, and other times it's not. We have many different versions of anomalous activity with gravitational prediction.
This is job.
Right, and mass and density distribution is one of them. Now, they are decently accurate at times. Seems to be maybe potential electric signature when you actually look at a correlation between the electric properties of different minerals, relative to their density. It seems to line up pretty well. And yeah, we have some anomalies. So using downward acceleration, right, to come up with things doesn't prove anything, because I just explained you can use something as simple as a kinematic equation to get that agreed upon average, which we just say is a constant for mathematical purposes. Actually, the consistent anomalies show that you got a problem, if anything, because if it was such a surefire science and every single time a certain mineral was under the ground, we'd get the exact same reading. We don't do that. We have anomalies, and there are like 20 different versions of anomalies with spring-loaded gravimeters and interferometry gravimeters. So, yeah, sure, we use a concept, a construction, but it doesn't mean that the convention is accurately defined conceptually, and your paradigm denies any type of Newtonian explanation conceptually. So the effect of downward acceleration, certainly on my behalf, is not disputed. It is much more the claimed cause of it, and the claimed cause is simply just a theory. It's like it's conceptual colloquial theory.
So the kinematic equations are just a way for you to measure the acceleration. That's it.
Yeah, you can also, of course, predict the rate with that equation.
Kinematic equations are a mathematical formalism for tracking the motion of objects without attributing any causes to the forces. Whereas what I just described, which is, for instance, there are so many lies that you manage to pack in there. A, gravity is not a constant. Gravity varies with position. It varies with altitude. It varies as a function of whether or not the weight of an object, the acceleration experienced by an object varies by how fast you're traveling and in what direction.
I just said that.
So that claim is false. You'll claim.
No, that's what I said.
You'll claim that. No, you claim that gravity is constant. You
no, I
made
didn't.
That multiple times.
No.
Yes, you did.
He didn't claim that. He didn't claim that. You're straw manning him. He did not.
No. Okay.
I've been sitting here listening.
I mean, I did hear him say that, but I think the context was wrong.
So there's an agreed upon average in which we treat as a constant value for mathematical conventional purposes.
Except we don't.
Tony, like
that is a lie. That is simply untrue.
Great.
Okay,
Appreciate
and you
your
can
content, right? But like, this is FTFE's event. If he needs you to defend gravity for him, I guess that's cool. But it's not really FTFE and all the Globers versus us, right? It's FTFE versus all the flat earthers. But I'll leave it up to him.
So
I mean, I don't mind Tony's expertise on the matter, and but Tony, I wanted to ask you a question just to verify something. Could could we use relativistic equations to get the same results that we do with Newtonian?
Yes.
But
Absolutely.
It would just be a lot more complicated, right?
No, Einstein's 1916 paper, in which he laid out the theory of general relativity, was required to agree with Newtonian theory when relativistic effects were small. So it was the fact that general relativity agrees with Newtonian theory in environments like Earth's surface is baked into general relativity. You will find that Newton's gravitational constant features in general relativity. It's still there. There's a constant that he introduces that takes its value from Newton's gravitational constant. So the claim that general relativity is inconsistent with Newtonian theory, particularly for an environment such as Earth, is false. I will also point
that's
out
another straw man fallacy. So I didn't say that.
He was just answering my question there, to be fair.
I'm answering Craig's question. I will also point out that we can verify the findings of general relativity and Newtonian theory at the same time, because gravitational time dilation is observed at Earth's surface. This contradicts.
No, it's not.
Yes, it is.
Muons. You're going to say muons.
No, I'm not going to say muons. That would be special relativity. I'm talking about
time dilation.
Yes, gravitational time dilation, not velocity-dependent time dilation. These are two different things.
You didn't specify.
Yes, I did. I said gravitational time dilation.
No, you didn't.
Yes, I did.
Okay, sorry, maybe I misheard it.
And you can try and you can try and lie about what I'm saying, but how about you pay attention to it?
Well, how about you let me respond to the first point? You just now ended up saying that they're mathematically interchangeable because of the constant value. You just now said I was stupid for saying that there's a constant value, and then you went on to say that the reason Newtonian and Einsteinian work together.
I didn't say you were stupid at all. What I said was you were incorrect. Gravitational time dilation is detected at Earth's surface, and it manifests itself in the wavelength of light, that is a wavelength of electromagnetic radiation that is being broadcast upwards and downwards. And they're working on experiments now that will demonstrate gravitational time dilation between quantum entangled particles. They can demonstrate gravitational time dilation. The higher the gravitational potential, the slower time travels. This is why we apply general relativistic corrections to GPS satellites, for instance, because gravity is much lower where the GPS satellites are. So in order to keep time correctly, we need to correct the clocks on them to accord for general relativistic effects. And we can detect gravitational time dilation on timescales as little as 30 centimeters, which is about a foot. So we can experimentally verify that Newton was right. And in the same moment, we can demonstrate that the value of gravitational potential at Earth's surface was approximately equal to what Newton derived. So these experiments demonstrate not only that gravitational time dilation exists and that therefore general relativity is correct, is accurate in a near-Earth environment, but we can also demonstrate the accuracy of Newton's formulation of Earth's gravitational potential.
Okay, so when I said that
that's why pilots stay looking so young.
When I said that we use the convention, the mathematical convention of a constant, even though it's not a constant, and then you proceeded to tell me I don't understand it, and you don't use a constant, and then you went on to explain, yeah, Einstein, and immediately interrupting me. So, and then you went on to say Einsteinian and Newtonian work together because you can actually get that same gravitational constant, right? And so that's the whole point, is that you're using a constant value that isn't actually constant for mathematical purposes and certain predictive capabilities. This isn't exclusive to the conceptual backing. When you say, oh yeah, Newtonian and Einsteinian, you can make the math go back and forth, that doesn't mean anything. right? Because when you're talking about a scientific theory, you're proposing a cause of an effect. You're claiming the effect of downward acceleration is a certain cause, okay? And conceptually speaking, when it comes to the causes, they're diametrically opposed, right? They do not coincide whatsoever. So basically what you're saying is, oh, well, we don't have a theory that works. Our theories contradict. We can pick and choose and use whichever one we want to, and Newtonian is simpler math, and we'll just use it, even though our own paradigm has proven that it's conceptually not viable, okay? And so this is where you just fall off the deep end into pseudoscience, where we're saying, yeah, we know there's an agreed upon average of downward acceleration. We can use a constant value for predictive capability. We can even use kinematic equations to do that, but we do not support your cause and effect claim, okay? That's the actual point.
None of what you said was meaningful or true. The term gravitational constant does not imply that gravitational acceleration is constant around the Earth.
Yeah.
The gravitational
I didn't say that.
Well, but you are referring to two different things. You're talking about this average value of gravity, which we take as constant. That's gravitational acceleration. That's completely different from Newton's gravitational constant. If you can't keep these two basic...
I know that.
Well, then why did you confuse them?
Because when you brought up applying it with engineering and other use cases, you're actually talking about little g. Now you want to come over to big G.
No,
and first of all, big G is not even defined conceptually. And this is what neither one of you guys will do. You will never actually address the fact that science is about a cause and effect relationship.
No,
you have a scientific theory, you're claiming a cause of the effect. And big G, hey man, big G is different than little g. Everyone knows that. All you can do is straw man basics, pretend I misunderstand them so that you can try to make me look stupid. Every time I give a specific response, you respond by saying, everything you said was wrong, right? But how about you actually address the point that they're conceptually opposed? They cannot coexist. They are not the same, and Newtonian mechanics does not work conceptually.
That doesn't make any sense. One is just an observation, the other is an explanation. Newton is this is happening. Einsteinian and the special relativity and general relativity is the why it's happening. They're not opposed in any way. One is just a more accurate explanation of what's going on.
They are opposed. One says that mass actually attracts another mass. One says
that's just an observation.
Mass causes a displacement of that mass within space-time, causes a gravity well, which bends and warps, causing things basically to be guided with the railroad down towards the center of mass of the other mass that is
which
bending
gives
and
us
warping
the
space.
force we can measure in Newtonian applications. They're the same thing.
Yes,
you went back to the math again. You see what I'm saying? So like.
Because it's a mathematical framework. If we're talking about relativity, we have to talk about mass because of the mathematical framework.
No, and if it's an accurate scientific theory, then it claims the cause of the effect, okay? So, first of all, what you're saying is Newtonian mechanics is useless when it comes to actual science because it doesn't even claim a cause. So you need to stick to your claimed cause. You're supposed to be trying to provide evidence that your claimed cause of the effects we see is the Earth being a ball in space-time, okay?
Mass attracting mass. That's it.
Okay, there are multiple errors in what Whitted is saying. A, the existence of gravity has nothing to do with the Earth being a ball. It is not caused by Earth being a ball. It does not. Gravity and the shape of the Earth are completely different, completely unrelated physical phenomena.
That's what made the Earth a ball.
Yes, because the Earth doesn't have sufficient materials. If you allow the Earth to have arbitrary material strength, then you can have gravity, and the Earth will not deform into a ball.
Well, then you also have to explain where water's bending around the Earth, and how there's a gravity well that holds the atmosphere beside the Earth in a vacuum, and what causes orbital trajectories, and what causes tidal locking of the moon. This is the entire globe model is based on the bending and warping of space-time causing a gravity well around the globe.
It isn't. So one is dependent on the other, but gravity is in no way dependent on the shape of the Earth.
Well, that's called a straw man. I said you need to defend, what you're supposed to be doing is defending the claim of gravity applied to this idea that there's a ball in a vacuum bending and warping space-time. When you just talk about the math over and over, you're not actually addressing your scientific burden.
No, you're mischaracterizing the nature of science.
Yeah.
Nature. So your assertion that science must have a cause and effect. Science must have a cause and effect before it can do anything. actually we can start quantifying and modeling something before we know what it is. And indeed, it is through this modeling and analysis that we get a better understanding of what it is. And your claim is that at some point we will reach perfect, and in fact you're claiming it now. You're claiming that science must have already arrived at a perfect understanding and characterization of every physical phenomenon in the universe. And if it hasn't, then we just throw it all away. That is in no way how science works. Science is an incremental and constant process. We are constantly improving our understanding of reality. So to say, Newton's laws of motion, for years and years, we didn't need Newton's law of gravity because we didn't have observations that required that were that important that needed to be explained by them. But eventually, we acquired more and more astronomical observations. Newton was able to come up with the theory. The theory was perfectly consistent with the observations. That's fine. After a while, problems started appearing in Newtonian physics. And the precession of the orbit of Mercury, and a number of other problems, and we needed to extend our physical understanding. And we did.
You talk a long time, man.
Yes, I do, and I didn't. And you should perhaps be listening to what I'm saying rather than looking for. Evidently, you
don't. Solid.
So, by the way, I am actually about to go eat. Right, you're very boring to me, but I dropped 3 different links. One from Berkeley explaining that quantum scale debunks Newtonian claims. So you can just say nuh-uh if you want to, but there's your own paradigm saying that is true, and I will drop like 5 more for you in just a second. So,
well, that's quantum physics.
And then basically, just as in my conclusion is that basically all he was saying was, oh, well, we don't even have to make a cause claim. We can just see things happen, make up math about it, and then pretend that we know the cause claim or that it's good enough at the time. And what we're saying is you actually can't prove that bending and working of space-time being a causal agent of things going down sometimes. It's just a claim. And then, you can deny it if you want to. You had to throw out the etheric framework to save heliocentrism. You can keep running around in your cult if you want to, but stop pretending it's a fact and that it's science.
You're gibbering meaninglessly. What you're talking about...
The gravitational
wow, dude, I'm getting out of here. I just talked for less than 20 seconds. You talk for 3 minutes at a time.
You're incredible on this. You get so uncomfortable. Right. You have to just...
Thanks for coming, Witsit.
Yeah, peace out.
Okay.
Shoots, Witsit. Let me know next time it's... What is that? Gambling. What's that called? Texas Hold'em?
Oh, poker, yeah. Yeah, my wife made dinner, so I'm going to eat it, but peace out.
This cause and effect argument is actually metaphysics. That's not actual physical science. And you flat earthers get caught up in it a lot. It doesn't matter if general relativity is completely correct or not. In fact, we know that it can't be completely correct. It doesn't matter that Newton's laws of motions are only valid in some portions of reality. As long as we understand the limitations of our knowledge, they remain useful. You don't just throw them away. You don't just discard it. You use the science that is appropriate to what you're looking at. For an architect, all they need to know is that G is about 9.81 meters per second squared, and engineers too. That's all they need to know, really.
Wait. Who said to throw anything away, though? Are you suggesting that flat earthers are saying that we shouldn't use what math and factual knowledge we know?
Yes.
Just because we're offering a separate explanation for something?
You're suggesting that we have to abandon Newton's laws of gravitation because general relativity exists.
Yeah. Well, you guys abandoned the ether model just because of one test, basically.
No, the whole of science abandoned the ether model, not just globers.
So
no, you're talking about practical application, not the actual theory itself.
Yes.
Like, for instance, the constant measure of gravity, right? Well, there's a constant effect going down, but attributing it to something else without confirmation is the idea of the whole question.
Except that we can confirm it because we use the rate at which things we design things called gravimeters. that measure the force of gravity or the acceleration due to gravity.
Tony versus the Discord server.
And we can use those to map. We can use those to map the way that gravity changes.
What's your best proof for a ball, Tony?
That would be Rayleigh waves. They're a particular form of seismic wave, and they travel from the epicenter of the earthquake around to the far side of the planet to the antipode, and then they come back to the epicenter, and then they go back to the antipode, and then they go back to the epicenter and back to the antipode, and they do this.
Where they go again? Where they come from? Hold on, one more time.
So let me just clarify. Shane was just trolling you. We all know it's the epicenter. You repeated it 7 times. So basically, what you're saying is you measure a shock wave, and because it matches some sort of globe maths, that's why it's a globe. Is that?
Do you want me so I can? I've got the last 3 videos I put up. It's not globe maths. So you put the seismometers out there. Okay, we've got a network of many thousands of seismometers. When an earthquake occurs, we can use the physical characteristics of each wave to identify the different phases. And there are these particular waves called Rayleigh waves. And they spread out from the epicenter, they go away from the epicenter, radiate away, and as they do, they start converging on the point opposite the epicenter, the antipode. And they converge on that point, they cross that point, and then they start moving back towards the antipode. So I can bring up a graphic of it if you want.
It looks like a ripple moving out from a certain point.
Yeah.
The ripples over a sphere instead of a flat surface of water.
Yes. And it does it multiple times, and indeed, and so they don't just do it the once; they do it 3 or 4 times for big enough earthquakes, and the same thing is observed for atmospheric pressure waves. So things like the Tonga Tapu, it's got a really long name, the Tonga.
I know what you're talking about. No worries.
That volcanic eruption. It caused a massive pressure wave that rang around the Earth for days, and it went in exactly the same pattern. It goes from the focus to the antipode, back to the focus. And
for days.
For days, yes.
Yeah, it was a bloody powerful wave.
And the same thing was observed. The same thing was observed for the Krakatoa eruption. Right, this was actually a social thing. Back in the late 19th century, lots of people bought barometers, and they noticed that air pressure tended to change slowly. And then after Krakatoa, everybody looked at it and they said, "Hang on, there's a kink there." And then a little while later, there was another kink and another kink after that. In that case, the pressure wave went around Earth 7 times before it eventually dissipated. It was detectable through 7 different. And if you imagine a barometer, you're going to see the first pressure wave you're going to see is coming directly from Krakatoa, and the second pressure wave you see is going to come from exactly the opposite direction. So it's going to come from behind Krakatoa and it's going to go back towards Krakatoa. So you've got all of these sensors all over the world, and they detect these waves doing these things, just radiating away from the source and then going back to the source, and they do it multiple times. And you can try and come up with an explanation on a flat Earth, but the explanation is, and you would have to invent some very, very simple, very, very exotic physics. But it's just clear that that's spheroidal. That's a spheroidal shape.
It matches the predictions of what a sphere would expect, which is what you do with science. You make predictions, and then you test it, and luckily the Tonga explosion gave us a massive test of the predictions, and it matched
so wait,
the predictions.
just for clarification,
PhD Tony, did you do any of these experiments yourself? I'm just curious.
Well, I mean, what do you mean by
sounds like a no?
Well, you mentioned two separate phenomena, right?
Yeah.
The seismic wave and the baryonic air pressure wave. Did you measure these after the Tongan explosion? Because I know.
What's that got to do with it?
The guy Moyak man claims.
These are global data sets, so I didn't obtain the data from every single site on the planet. I did plot up the data for the Macquarie Rise earthquake of 2004. That's a good one because it's near Antarctica, so you can see the waves radiating out and converging on the antipode. So I obtained the data from a public repository. There's a seismological data repository called IRIS. They will allow you to download data for any event.
Tony, do you know who Moyak Man is?
What?
No.
Moyak Man is another guy who comes around the Flat Earth and around our servers, and he actually claims that he personally measured the seismic activity from the Tongan explosion. I just thought maybe if you knew him, you two could collaborate.
So I work at an earth sciences research school. That's what my PhD is in, is geophysics, and in particular studying Earth's gravitational field. At the moment, I work on satellite gravimetry, setting up satellite gravimetry stuff. But I have worked in the seismology department, and in fact, my PhD thesis was on adapting a flat Earth seismic model. Now we use flat Earth seismic models.
Are you serious?
I'm perfectly serious. Yes. We use flat Earth seismic models a lot over small areas, areas of a few kilometers or so, when we're looking for subsurface mineral, oil, or gas deposits. We use these flat Earth models, and we try and analyze the seismic data because it doesn't make much difference, and the mathematics is a lot simpler. So I'm an expert in flat Earth seismic models. Well, a bit of an expert. It's actually not my primary focus, but.
What your primary focus is?
You don't use gravity in those models, do you? Because that'd be weird.
No, we don't use gravity in those seismic models. No. So my primary focus now is Earth's gravity. My primary focus has also always been sea level and sea level change. I study that formally. So that some of the thing, a lot of flat earthers seem quite confused about the concept of sea level and how water behaves.
About tides? Can I ask about tides quickly?
Sure.
You're an expert, right? So.
Yep.
So the last full moon, it was maybe 3 or 4 days ago.
Mm-hmm.
I was at my friend's house. He lives on the beach. He has basically, on a normal average, the water is about a foot for about maybe 200 yards, and then there's a drop off. But the other day, it was weird because I saw the full moon rise and come over the course of a couple hours. He's my good friend, so I was at his house for a couple hours just hanging out. But the full moon rose from the horizon and came to the top view over a good amount of time, and I observed that the tide was actually low. All the seaweed, all the sand, all the rocks and stuff, they were all exposed. It was a low tide. But it was a low tide corresponding with the same time as a full moon. So I thought that the full moon was supposed to indicate a high tide. So maybe you can explain that.
So the with the full moon has the effect of you've got moon's gravity on the opposite side from the sun. So the full moon isn't perfectly aligned with tidal sequences. So I'm not as expert in tides as you might imagine. My supervisor would be a much better person to talk to. But you're still going to get a low tide to high tide variation during a day. But those high tides are going to be higher when the moon and the sun are on the same side of you, actually. So actually it's during the new moon that that you're going to get really high tides because their gravitational signatures pick up. And then during the year, there are points in the year where you're actually closer to the sun, and so it exerts a bigger gravitational effect, and where the moon might be closer to Earth, and that's going to have a bigger gravitational effect. So you're going to see really big high tides during that sequence. Okay, so there are actually sort of there's this obscure terminology with tides. So there are neap tides, and there are mean high water tides, and summer tides, and all of this sort of stuff. So there are various tides that people refer to. So yeah, generally, actually, when you've got the moon and the sun on opposite sides of Earth, that's actually going to reduce the tidal amplitude rather than increase it, unless the moon is particularly to Earth.
So the full moon is usually a low tide, is what you're saying?
Yeah, the full moon...
Okay, I didn't know that before. The other night, I was literally at his house, and it was a full moon. And, legit, for 200 yards, there was no water. It was all just sand and exposed coral. And I was just... Because I come to these Flat Earth servers, right? So I was just thinking, I got to mention this to someone. But I didn't tell anyone until now because you just mentioned that you're kind of you study water level. And I would assume tides is linked to that.
Yeah, so we do... we do say that. I noticed that Shane is very skeptical about the fact that I demonstrated. We do use gravity a lot for practical industrial purposes, and so I'm uncertain why.
Yeah, Tony, I remain very skeptical. I think that's an astute observation.
Yeah, Shane is a skeptic, and I'm saying that with air quotes.
That's okay, but can I ask why? You don't believe in gravimetric surveying? Did you even Google it? Did you try?
Well, no, I haven't done any of that, right? I think you gave me the education I need to say that. As in the words of FTFE, I don't know enough about it, but I know that you're wrong.
How so?
So
that's kind of misquoting me.
Come on, I'm going to make it a meme. I'm going to pass it.
Yeah. Make me right. I said his conclusion is incorrect, and I can explain why. Trust me. Witsit has done me a massive favor, right? And it's a strange thing to say about a flat earther, but he's made me increase my knowledge quite a lot. I've had to do a lot of studying so that I can succinctly debunk the nonsense that he's been spouting, and I'm going to do it. But learning new things is a great thing. Tony, I really appreciate the assist. I've been on new medication this past week and I've been feeling a bit ill, so thank you very much for coming in. I always appreciate having a real person in the room, because the rest of you do know that you're not a real person unless you've got a PhD, right?
Even then,
yeah.
I thought you're not real unless you talk on Discord or YouTube, but that's just my thing.
So Tony, wait, I've got 2 bachelors. So what percentage of a real person am I?
As much as a percentage of your tight shirt.
Oh, my tight shirts aren't that tight anymore.
You're making me sad now. You gotta have tight shirts, or else you're not the same.
You're about 25% of the way.
25%. So I'm 25% human. I can take that. Right, guys. I'm going to be finishing up soon. It's quite late. I appreciate the conversation today. Is there any flat earthers here that hold the position that density and buoyancy is gravity?
Yo, FTFE.
Nobody thinks that.
FTFT. I wanna. Let me find this. I want you to argue with this. Argue about this next time. Here, I'll post it in the chat. 57 after the hour. You know who Jesse is?
Just
like, you know, these more simple proofs, it's more simple globe proofs. I like these more, man. Like, fuck relativity, fuck gravity, fuck all that quantum fucking bullshit.
Yeah. I like simple ones as well. But the problem with simple observations is that flat earthers don't and never will understand perspective.
we say the same thing about you guys. It's funny.
Trust me, engineers know perspective. So there is no flat earthers here that hold the position that density and buoyancy replace gravity. You know, that's an Eric Dubé special. None of you agree with that, right?
No, I don't hold that. Like, if I could word it from my understanding of it, right, is that the only thing that we're replacing is just the general downward non-zero magnitude vector, right? And we say that's the electrostatic downward vector. And everything else, density, buoyancy, viscosity, sort everything else out as far as why things go down, right? But the thing that determines the vector is the electrostatic. That's how I think I'd word it.
Isn't density independent of gravity and buoyancy dependent on gravity?
Yeah, well, buoyancy has G in its formula, rho GV. So
therefore, right.
You need a downward acceleration to calculate your buoyant force. Density is just the amount of stuff in, you know, a certain place.
Right. So the same way, if you cross out that G and just use 9.8, like, that's exactly the same thing. They don't actually cause gravity. They just use the measured accepted average downward acceleration in the calculation.
But again,
I don't think buoyancy
we can actually derive that acceleration using gravity. You know, we can explain exactly why that acceleration happens, you know, and the maths and everything behind it, you know, whereas electrostatics doesn't explain so much. Like I was explaining to Witsit, electrostatics falls apart with the simple fact that, you know, a ton of lead and a ton of, you know, I don't know, ultramagnets will fall at the same speed. You know, they shouldn't. If it's electrostatics, then something that is more reactive to electromagnetic forces would have different accelerations applied to it. You know,
FTFE. I have a question.
That's begging the question.
It's not begging the question. It's what physics says would happen.
You're begging the question with that G.
What G? The downward acceleration.
And the downward acceleration. Yes.
There's no begging the question. That's measured.
Yeah, but I don't want to speak for Witsit, but I do think that he does believe density as being a big. Like, I do think that Witsit is a fan of. It's a combination of the electrostatics and density, right? So it's not just the electrostatics that are at play. I'm pretty sure.
So it's the general consensus here in this server that it's an electrostatics, it's you know, an electromagnetic phenomenon that causes the acceleration we experience.
No, I don't think.
No,
we don't have very many consensus.
No, that is not. No, I'm just gonna say no to that.
The general consensus is solids fall down. That's a general consensus.
Yo, FTFE, I just want to ask a simple question before you go.
Yeah.
Who you said Witsit? You're thankful to Witsit because he made you think and learn about things. Would you say? Who would you say is the best flat Earth debater or the most logical flat earther that you've met so far?
Oh well, there's no logical flat earthers.
Just relatively. Like, who is the least illogical?
Poisoning the web.
Who's the least illogical in your
Who's the least logical
opinion?
that I've spoken to? That's a very hard question.
Least illogical. Wow.
So, because I kind of want to beat your best flat earther, to be honest. Like, I want to see who your best flat earther is, and I want to outdo him.
They're always confused as each other. I mean, I think it's clear that I don't want to say the hardest to debate, but the biggest challenge that I've had debating has been Witsit because he spoke of things that I don't know of. Whereas
so I'm hanging out with the right guy, eh?
In general, the conversations I have with flat earthers are a lot less full of someone who's actually done some reading and stuff, and it's just, you're an idiot. I'm not saying that Witsit was right or beat me in debate, but he, you know, because he was talking about things I didn't understand, I had to learn more. And he's given me a challenge because I've had to learn more things. I appreciate that.
If it helps you, I think he beat you.
Yeah, I think he
well, remember when he just kept saying, "Let's agree to disagree with any of my evidence." That doesn't. Yeah, being wrong about relativity doesn't mean that he won a debate, and we were both wrong about relativity. It's the other stuff.
No, you didn't even know what he was talking about so recently. That's why
I had surface level knowledge, but it's something that I'd never gone deep into because I've only got a bachelor's in physics, and it's something I've never really had to study that much.
Craig, wouldn't it be okay if you had a record of debates of like 652 to like 1? Why don't you just give us that one? Just go ahead and say you lost it. It's all right.
Well, I did lose one debate, and that was to Mallory, but that was because she showed me furry foot fetish porn.
Two then.
I think PhD Tony's trying to say something. Can we let Tony say what he's saying?
I will say that actually Whitsitt is in many ways the least impressive flat earther that I've come across.
Oh, okay.
Because
can I actually chime in with
PhD Tony
something
finish
now
saying,
at last?
just
Gin CBR1.
Yeah, just let Tony finish what he's saying.
Don't worry, carry on. I just I can expand on why I think that, but I actually Whitsitt seems more maliciously deceptive than most flat earthers. You guys here, the vast majority of the people that I've talked to here, are asking honest questions and seem confused about stuff. Okay, that's fine. But you seem honest.
More maliciously.
We're not confused. Can I now
the flat Earth model?
Can I speak now, please?
Yeah. Right. Yeah. I'll give 10 minutes with you, and then I have to go. What's your name?
Possible. I've been hanging around for a couple of hours.
Okay. Hello. How are you doing?
In CBR1. Number one. My friend, please. I'm not your friend at the moment. Look, pay attention. I want to debate you personally. I want to debate with you personally. My name is Jin CBR1.
Hello, Jin.
The loudest flat earther you will ever hear this server.
I
listen
don't know.
up. There's no hellos here.
Hello.
In the question a lot. So if you don't debate Jin CBR1, it means you're scared. It means
I'll debate you, Jin.
Scared. That's what it means. Okay.
Yeah, Jin, I'll debate you, Jin.
I'm demanding a challenge for you to debate Jin CBR1. Yeah, right.
Yeah, cool.
Okay, because I'm fed up with your assuming consequences and everything.
I never do any of that,
fallacies
but whatever.
You carry. Assumptions, fallacies. You don't have a globe at the moment.
All right.
Yes, you do. You haven't.
We'll catch you, FTFE.
There's one in my hand.
There is no curvature at the moment.
There's lots of curvature.
We don't have any curvature. Today's latest, pay attention, today's cutting-edge technology is unable to find the curvature of the Earth.
Incorrect.
That's the current situation.
100%
Today's
incorrect.
cutting-edge technologies are unable to prove the curvature of the Earth.
100% incorrect.
So when you're ready to debate a real debater...
I mean, you're definitely not a real debater, but I'll debate you.
Real debater, let me know.
Do you know a real debater, Jen? Are you going to introduce me to one?
All the time, for a lot.
So,
for those...
Jen, are you proposing to introduce me to a real debater?
Sounds like the master debater to me.
Real debate.
It will
be a real debate. It will be a real
Yeah, well,
debate.
Jen, my email is flight the flatter. Jen, 2 ears, 1 mouth. Time to use them in that ratio.
Make sure it's amicable, because if you want amicable, I can give you that.
Okay, Jen. So my email is flighttheflatearth@gmail.com, or you can DM me here on Discord, and we can arrange debate. Yep.
Hey, we have Jin and I. Jin and I are next Tuesday. Week from Tuesday.
Oh my! You're gonna. Well,
you and Jin.
Get a little sample there. Looking forward to it, Jin.
Nicktoon, you're a champ, bro. You're gonna debate Jin.
Am I allowed to get a question before we go? You said there was no logical flat earthers. I'd like to ask a logical question.
Please go ahead.
Ah, thank you. So we were talking earlier about the Coriolis, and you last time we spoke, you said that we weren't allowed to use motorized vehicles. But I got to thinking about that, and that kind of, when we were doing it,
What do you mean? I
took
said
away
you're
the
not allowed
wind,
to
we
use
took away
motorized
motorized
vehicles. I mean, I agree
vehicles.
flat earthers shouldn't have a driving license, but
Yeah.
That's quite ridiculous.
So, the problem is that if what I was trying to pose to you, if a helicopter takes off, then the Earth should rotate. You said no, conservation of momentum, right? It's conservation of momentum, right?
And the fact that it uses the atmosphere, which rotates with the Earth.
And atmospheric drag. Okay, so atmospheric drag. So now, if conservation of momentum and the atmospheric drag are pulling this helicopter along, this helicopter is not always in forward motion like a plane. It can hover. So what stops this helicopter from going against the spin of the Earth and losing at max flight for 3 hours, max speed at 3 hours? How much forward momentum would it lose, or its initial momentum would it lose? Then it should be able to hover.
Would it lose?
Well, supposedly we're already going with the Earth, so we'll define that as forward, yeah? For the purposes of this argument.
Well, no, that would be stationary in respect to the Earth.
May I answer?
No, you're saying it's a conservation of momentum, so there is motion naturally.
Yeah, yeah, okay, but with respect to the Earth, it's stationary, right? Do you agree with that?
Yes, it's landed. Yeah, it's on when it's on the Earth. Yes,
yeah,
but no, I agree with that.
Even when it's hovering, even when it's just hovering above the Earth, with respect to the Earth, it's still stationary.
Mm-hmm. Right. So now, upon initial takeoff, sure. Now, even like I said,
hovering. It can hover there for 3 hours, and hovering is
That's
stationary.
Right. We already went over that. I get that. I hear you. When you first take off and you're hovering, you should still have all the momentum you were just had on the ground, and you're floating along with the Earth and the atmosphere. I get it. But what happens when this helicopter goes against the spin of the Earth for hours at max speed? It would lose much or all of that conservation of momentum, and it would then be able to hover and watch the Earth spin.
No,
because it's been flying against the spin of the Earth.
Incorrect. It uses the atmosphere that moves with the Earth. The atmosphere is always moving with the Earth. So if the helicopter is hovering, it's moving with the Earth.
Right, but if it's flying against it, it would lose its initial momentum. Is the whole point?
No, because it's still using the atmosphere.
No.
It's using the atmosphere, which is moving with it. Right. PhD Tony wants to answer this, so just PhD Tony, please.
Yeah,
well, I wasn't asking him. I thought this was you versus us. I asked you a logical question. I don't want you to refer it to somebody else.
Right, okay, no, that's fine if you...
I'm asking you if a helicopter can hover, and you're saying that conservation of momentum stops it from visually watching the Earth spin underneath it. I'm saying it can fly against the Earth and lose that momentum, and then watch the Earth spin underneath it, because it can hover. It's not stuck forward.
But again, it will be, if it's hovering, it's in the atmosphere, which is rotating with the Earth. So for it to move, like with the Earth going underneath it, it would have to be applying a force to move. If it's just hovering, it's moving with the Earth. Yes, because the atmosphere is moving with the Earth.
You're leaving out a very crucial part.
Wait. The atmosphere is moving with the Earth. Yeah. You understand that? Like
right.
1-to-1, the atmosphere...
Yes, I do understand that.
Yeah,
but you're leaving out
therefore,
part of the
if the helicopter is hovering... Let me answer. Would you like me to answer the question or not?
The spin of the Earth.
Would you like me to answer the question or not? Would you like me to answer the question, or are you just going to keep talking?
Well, I've been waiting patiently.
Right, let me answer the question then.
Go ahead.
If the helicopter is hovering, it is moving with the Earth because it is in the atmosphere.
Right.
When it is moving independently, it's applying a force to go one way or the other, and then it will apply a force to decelerate and get back in lockstep with the Earth. But if it is hovering, it is always going to be moving with the Earth because the atmosphere moves with the Earth. Otherwise, it would be going to the west at 1,000 miles an hour at the equator. Again, and that would be a wind for it. No, that's how a helicopter hovers. It uses the atmosphere.
No, I didn't say all that. I'm saying that when it takes off, it has conservation of momentum, and that would explain it hovering in place.
Well, it's more the atmosphere, to be honest. Like I said, it's the fact that it's the fact that a helicopter uses.
No. I let you go off, and it's my turn now.
It's the fact that a helicopter uses the atmosphere.
Yeah, you're just going to run over me because you know you can't answer it. The helicopter's going against the spin of the Earth loses its momentum, therefore it should be a new speed factor. One without the conservation of momentum.
Speed factor? No, because it's always relative to the surface of the Earth. Right. Okay. Right. Do you know what the difference between airspeed and the ground speed is?
Yeah, I mean, you're just going to keep talking. You're not really listening.
I am listening and I'm answering you, but do you know the difference between the airspeed and the ground speed?
You're not. You're what? Can I look? I'll tell you what you've answered to me. I'll say it to you in a different way. Okay?
Right. So again, when the helicopter, when the helicopter is hovering.
There you go. Right, there you go. No. Fuck that.
Will you let me answer your question, or are you just going to keep talking because you're too scared to hear the answer? Is that right?
You're an asshole, man.
Because I'm trying to answer your question, that makes me an asshole. All right then, dickface. Your mum likes me, so you know.
I can't find a logical because I can't shut me god long enough to find one.
I'm trying to answer your question, but you won't shut the fuck up long enough to let me, dickface.
Salty, I totally warned you, right?
Fuck off.
All right.
The helicopter hovers, and you are correct. Yes. If the helicopter specifically flies against the spin of the Earth, it is losing its momentum with the Earth. It's flying against it. It's a motorized vehicle against the atmosphere,
which has that momentum.
Therefore, it would have the power to keep moving against the atmosphere and should have.
Can you please show me the maths to back that up?
I'll lose that.
Can you show me the maths to back that up? Because that's completely against Newton's laws of motion.
Once you resume hovering, then after the trip, you fly against it for 3-4 hours of flight at max speed, and then you hover again. You should be able to watch the Earth spin underneath you because you've lost your conservation of momentum.
You're just going completely against Newton's laws of motion. Right, so a helicopter hovers, it's using the atmosphere, right, which rotates with the Earth, and then it starts going, say east, right? It's applying a force.
No,
let me talk, right? So it goes against the spin of the Earth, right? Or, the opposite way that the Earth is spinning. It's still in the atmosphere, which is giving it lift, which has momentum with the Earth, right? And it's applying a force to accelerate to move one way. It will then apply more force to decelerate and get back into, line with the Earth because it's using the atmosphere to hover. It can't hover and move separately to the Earth. If it's hovering, it's always going to be moving with the Earth because the atmosphere is the medium that gives it. I'm still talking. I'm still talking. The atmosphere is the medium that gives the helicopter lift, and that atmosphere always maintains motion relative to the ground.
Right. Well, regardless, that motion against the spin of the Earth should not only negate the atmospheric push against it, it should show measurable difference in it.
Could you show me the math to back up that claim, please?
You would have to say that this is moving straight up off the Earth. Now everything's moving at the same speed. The helicopter goes against the speed, swims upriver, so to speak. When it stops going against the spin of the Earth and the atmosphere, it's going to have whatever brief amount of time it is that it should be able to resume stationary hover and watch the Earth go, like you said, until it gets back in line with the spin of the Earth. It's going to take a while for it to get back up to speed.
Yeah, that's why you decelerate and accelerate relative to the ground, yes. But whatever's happening, it's always maintaining its motion relative to the ground because the atmosphere is moving with the ground.
So you're saying that helicopters can't fly whichever way the Earth is spinning. They can't fly against it. There's no motion that way.
No, I never said that. But even if, so if you were at the equator, right, and the helicopter was moving the opposite way of Earth's rotation at 500 miles an hour, it would technically still be moving with the Earth's rotation at 500 miles an hour because it's the 1,000 that it's already moving minus the 500 that it is going against the rotation. But that still means that it's technically going 500 miles an hour with the Earth's rotation, even though relative to the ground, it's going the other way.
Right, which is half of its original conserved momentum.
Yeah, but then it applies a force. But then it applies a force to decelerate. Right? Hold on, let me finish. Let me finish. Right, but then it applies a force. Then it applies a force to decelerate. Right. That doesn't just happen. You have to apply a force to make something decelerate. So a plane, a helicopter, whatever, is going to apply that force to decelerate relative to the ground, and then it's going to be hovering again. It's all relative to the ground because the atmosphere moves with the ground.
Right, but on a spinning ball with the atmosphere moving against it, there's one special direction that will change the conserved momentum of every object.
It moves with it.
No, it can't. Well, of course, because it would be overpowered by it. But still, even like you said, by the atmosphere, it's going 1,000 miles an hour. We said it was at the equator, 1,038 miles an hour.
Yeah, so that's from an outside reference frame. If you were looking like outside of the Earth looking in, it would still be moving with the Earth's rotation at 500 miles an hour.
Right? Can I finish? Can I finish?
I'm trying to explain to you the answer.
I don't need you to explain. I need you to stop explaining.
You need a physics lesson.
What I'm saying. You're interrupting me and being rude as fuck right now.
You've been rude this whole time.
I don't get like this with people. No, I haven't. I've been trying to explain. You haven't known how to shut the fuck up. Conversation into something it's not.
I mean, teaching you basic physics. That's what it is.
Question to you, and you're saying that as soon as the helicopter stops going against the speed of the Earth, or against the spin of the Earth, it's immediately resuming its 1,000 mile an hour conserved momentum of original start point, even though it was going 500 miles an hour less.
Yeah, because it has applied a force to decelerate from that 500 miles an hour down to a 0 miles an hour relative to the ground. Because it's using the atmosphere. The atmosphere isn't separate to the ground. The plane is always using the atmosphere. The helicopter is always using the atmosphere that is moving with the ground. So it's always relative to the ground as, stationary because the atmosphere is moving with it. So that's why if a helicopter is hovering, it's stationary. You have to apply a force to accelerate and then a force to decelerate. And then you're stationary.
Can I have a crack at this? Yeah, because of the closed helicopter. Yeah, I get it.
So, anyway.
Can I have a crack at this?
Yeah, oh, yeah. Hey, Rufus, how you doing?
Hello. Lovely.
Yeah, please go ahead.
Salty. Yeah. Oh, I can't stay long, so anyway. So, Salty, when this thing takes off, right, the Earth is moving at 1,000 miles an hour and the helicopter's hovering. If we're sitting out in space, it's also moving at 1,000 miles an hour. Cool. Right. Mm-hmm. If the helicopter then starts to head west at 100 miles an hour, we're going to ignore the atmosphere for now, right? We'll bring the atmosphere in shortly, but it's heading west at 100 miles an hour. If you're sitting out in space, right, you will still see the Earth moving at 1,000 miles an hour, but you'll see the helicopter move at 900 miles an hour because it's moving west at 100 miles an hour.
Right. Cool? Correct. Yes. Right. Yes. Correct. You're with me right so far. Yeah. Mm-hmm.
Okay. So now you're saying if the helicopter hovers again, right? It's stopping with relation to the Earth. So it's taken off its 100 miles an hour. It's back to going 1,000 miles an hour with the Earth, right?
Oh, come on. Well, no. That's not an instantaneous. That's my whole point of what I was trying to say to this man was that it's not an instantaneous thing. You can't imagine logically to go from he already was talking. We said 500 miles an hour. That's chopping the whole speed of it in half. So that would be a noticeable thing. If you're going half the speed of it, you don't just instantaneously go.
No, that's why I said there's acceleration
and deceleration.
Yeah, acceleration and deceleration are important.
Right, we're slowing down. We're going 100 miles an hour.
If you say that hover means that you're back going with the Earth, then yeah, I guess you're trying to weasel out. I'm talking about to not have any more forward acceleration, not technically hover, if that's how you're trying to squeeze out of it.
You're heading west. You're heading west at 100 miles an hour relative to the ground, right? If you slow down to 0 miles an hour, you have applied a force.
Deceleration.
Right? Yeah. Please. Yes. Deceleration, acceleration, whatever. You applied a force to slow down. Once you've done that, however long it takes, you're back to 0 miles an hour relative to the ground, and from your inertial reference frame out in space, they're still both moving at 1,000 miles an hour.
No, what you're saying negates the helicopter's flight.
Why would it?
What do you mean?
In a certain direction.
No. It's over a different point from where it took off. Like it took off and then traveled 100 miles an hour west.
Well, how can that be if it's going 1,000 miles an hour and the ground is 1,000 miles an hour and the air is 1,000 miles an hour? All those numbers match up. So it's not going nowhere.
We said that we accelerated to 100 miles an hour. west, right? So now, from the inertial reference frame out in space, wherever, it's going 900 miles an hour east.
Right.
Okay, so what's the problem?
The problem is that once you stop going, the problem is I'm wording it wrong, and you're finding a little loophole in here in my wording. The problem is that hover doesn't mean go back to 1,000. Hover means stop moving forward and watch what the Earth does. If it's going to spin underneath,
keep going 100 miles an hour?
Well, whatever the case is, we discussed 500. There's been multiple numbers brought up. It was 500, and then it's 100. But like I said, let's say 500 again. However fast a helicopter can fly. That's how fast we're talking about.
Okay. So we're ignoring atmosphere.
No, we're not ignoring atmosphere. We're not ignoring atmosphere at all. Because that's the whole reason why it stays stationary on initial takeoff. I'm talking about flying for hours and hours against the spin of the Earth, and you lose that forward momentum. You're not being carried by the Earth or the atmosphere as much anymore.
You're applying a force westward.
Right. So it's not only the helicopter's power of 500 miles an hour. You're also trickle draining off of the forward momentum that you had initially.
By applying a force, yes.
Yes, by applying a force. And then when you take away that force, you would assume that 1,000 mile an hour wind is going to catch this helicopter and scoop it along, and no one's going to notice it, huh?
What wind?
So, this is kind of why I wanted to ignore the atmosphere.
Well, that's what it effectively would be if you were negating the atmosphere, and then suddenly the atmosphere
negating the atmosphere. The atmosphere is the reason the helicopter's flying.
But when he said we take away that force, what he means is to stop pushing westwards, and then, of course, if you're traveling 500 miles an hour, the atmosphere will apply a force to you, because it's traveling 500 miles an hour the other way.
That's why it's important to fly for a few hours to negate that forward momentum that you had upon takeoff.
Right.
So now there isn't 1,000 mile an hour.
But you never negate that because the atmosphere.
We're flying west at 500. We're flying west at 500, but from the inertial reference frame, we're flying east at 500, right? If you stop applying a force, yes, you will still have that 500 miles an hour heading west relative to the Earth, but the atmosphere will slow you down to get you back to hovering again. The atmosphere is applying a force eastwards.
Right.
So what's the fucking problem?
Like I'm saying, regardless of that, the helicopter is maintaining its speed, and the only reason why it's not going slower or faster is because of conserved momentum.
Right.
No, and the atmosphere.
You do have to apply a force.
Saying that the momentum of when the helicopter is on the ground, it's moving 1,000 miles an hour. The atmosphere is moving 1,000 miles an hour. The helicopter takes off. It is still going 1,000 miles an hour. So not only when you go against the spin of the Earth are you going the speed of the helicopter, even if let's say you're right, which I'm sure it sounds logical, that the atmosphere would push back against the helicopter. Of course it would, and it would reduce its speed to 300. So it can fly max speed of 500, but because of the pushback against the atmosphere, it's only 300 miles an hour. Even still, every second it's going against the spin of the Earth, it's losing its initial forward momentum on top of the speed of the helicopter. It's not just the helicopter.
Only if it's continually applying a force westwards. When you say you stop it, then there's no more force applied, and then you've got the atmosphere. Like you would have some speed relative to the atmosphere, and then you'd be hitting the atmosphere, and that will be applying a force, slowing you down, such that you'll eventually get back to hovering at 1,000 miles an hour.
Eventually get back into hovering, but until that eventually comes around, the Earth should be underneath you, spinning underneath you.
And what do you think that would look like? Would that look like you traveling west at 500 miles an hour?
Yes. I think a better way to explain it is you'd be going X amount going against the rotation, but as you go back to a hover, you could even, in a flat earther's mind, it works in my mind, where you would almost be increasing your speed to match the Earth's rotation again.
Yeah,
right.
in the inertial reference frame.
Back with the spin of the Earth to catch up with the initial momentum conservation.
Like you're just going to a stop point.
This is so fundamental. Like, this is why I try to take out the atmosphere, because this is such fundamentally simple.
I would like to add my piece. One sec. Let me just. I think the atmosphere is important because the atmosphere is conserving its momentum, right? The atmosphere is conserving the momentum of the helicopter with the Earth, because that's the medium by which it's giving its lift, right?
Yeah, the lift, right? The lift, yes, but take out the atmosphere just for the east to west, right?
Yeah.
Just imagine helicopters hover magically without fucking atmosphere. So much simpler.
No, the atmosphere makes it happen. That's what I'm trying to tell you. You're saying that conservation of momentum stops the helicopter from going straight up and watching the Earth spin out from underneath it.
Yeah, but what would it look like? What do you think it would look like?
I think it would look like a ball spinning underneath you. The land would be moving while you're hovering.
It would look like you're flying west. Would it look like you're flying west?
Yeah, it would, but if you knew that you were actually brought back to hovering 0 and not going west anymore, you would be able to attribute it to the Earth's motion and not the helicopter's.
No. Oh, this is such...
Well, let me have a bite at the cherry. Can I have a bite at the cherry now? Basically, look, car traveling at 60 miles per hour with a drone on the roof of the car. You switch the drone on now, the drone, and you fly up. What happens to the car? The car's gone, and the thing's hovering.
Yeah,
so what the man, what Sully was saying about the helicopter?
No, we're just doing physics here.
No. Yeah, right. So what Sully is saying about the helicopter hovering and the Earth don't interrupt now, and the Earth should be rotating underneath the helicopter is absolutely correct. But we don't have any visuals of this from any satellite footage anywhere on Earth. Never been seen. Remember, the Earth itself hasn't been established as a globe. So everything you're talking about is speculation at the moment.
Basic laws, just like Rahif said.
Salty, this...
We don't have this in the real world. None of us have seen it.
I can show you a video of it right now.
None of us have seen what you claim. No, he hasn't. He's giving you a... He knows you.
I can show you a video of it right now.
We've never seen it. None of us have seen it. We don't have any videos of it. We've never seen this in our lives. Let's remember that. You need to prove that globe. No, it's not happening now. No, that's a lie. That's a begging the question fallacy with no scientific evidence, no proof. Words.
I've got flight radar 44 it's showing helicopters hovering all over the globe.
Crazy, right?
Just this idea of relative motion.
The globe.
They don't understand that at all.
We don't have the globe. That's the problem.
Yeah. I mean, we definitely do.
No, you don't fucking get it, Ruhev. And Ruhev, do you remember? No, we don't. We don't. It's not established anywhere. No,
I remember you saying, in fact, I remember Jin, I asked him to repeat this. So Jin repeated the phrase after me that 0.03 is greater than 9.8. No, you did. You already have. 0.3 is greater than 9.8, right, Jin?
As far as I'm concerned, 1.5 times the speed of sound is not slow. Okay? And like I said,
0.03.
Salty said is correct.
I mean,
ignoring what Salty said,
1.5 times the speed of sound is really slow compared to, say, the speed of light.
Would be independent of the Earth ball.
But
You're
why would
ignoring the facts.
Okay, so there's the generosity. Look, I even went as far to try to give you the motion of the Earth, which the helicopter disproves on its own. But I tried to even give you the helicopter and conservation of momentum. Fine, we'll go from there. This is a thing that can fly and just hover. It doesn't have to go back and forth like a plane has to go forward or else it'll crash. You know?
What?
This thing can lose and gain momentum. A plane has to go forward, or while it's in motion, while it's in use and flying, it has to be going forward, or else it'll crash.
You know, like force, right?
It can't hover.
Has to, that's what engines are for.
Right.
Yeah. Okay. It has to apply a force. Sure.
Yeah.
Yes.
In fact,
what is the problem? Please explain your problem.
It doesn't have to apply.
I told you. I already told you the problem is here. Look, the problem is that you're already going 1,000 miles an hour. The helicopter has its own constant push against the spin of the Earth and the helicopter and the atmosphere. You said.
What's the 1,000 miles an hour? What is that relative to? Because speed is relative, right?
Everything at the equator.
Yeah, at an inertial reference frame in space, wherever.
Yeah. So there is a tangential velocity at the equator of 1,000 miles an hour relative to an inertial reference frame out in space, right? and everything on the Earth, including the atmosphere, and everything is moving with it. So when the helicopter takes off, it's not just the conservation of momentum that's keeping it there. It's the fact that it's using the atmosphere that is moving with the Earth. And then if it wants to travel against the Earth's rotation, all it's got to do is apply a force to go a particular direction. And then it's still moving relative to the surface of the Earth. And then all it's got to do is slow. All it's got to do then is slow down, and it's going to be moving relative to the surface of the Earth at 0 velocity. So it's going to be from the outside reference frame going at 1,000 miles an hour. It's basic relative motion.
No,
it leaves us with the argument: is the Earth actually
miles an hour for hours and hours and hours, and still magically maintain 1,000-mile-an-hour speed?
Because
what you're
the
saying
atmosphere is what he's using.
A helicopter.
Can we take the atmosphere out just so they get the relative motion?
Well, that's the problem. He's thinking because
don't do that because we understand the movement would just disappear. We understand what we're saying.
I mean,
he's saying you start going 1,000 miles an hour westwards and then stop applying a force, right? My point in taking out the atmosphere is saying, if you stop applying a force, then you'll keep seeing the ground move underneath you at 1,000 miles an hour. That's fine. That's why I want to take the atmosphere out, just so they get the fundamentals right.
When you take it out, so you're saying these laws would apply if the Earth wasn't moving. Anything would happen.
Right, so that means the higher you go, the more the ground's going to move underneath you, right?
The faster you go, yeah. You would see that as the pilot just traveling west. That's what you would see.
Anyway, but that's not. Yeah, but look. It's not because of the helicopter. It's because of the Earth's spin. That's the difference. That's the whole difference in everything. Whether
it's just relative motion.
Whether the helicopter is pushing you west or whether the Earth is spinning underneath you is the whole experiment. So you saying no, that doesn't compute. This whole thing is about that issue right there.
Yeah, it's indistinguishable. You can't distinguish between them.
Right, so how high do you go before you can?
Shane, I do need to leave, so I'm going to say goodbye.
Okay, cool.
Right.
See you, FTP.
Thank you everyone for letting me in again. Hey, Ruhif, good for you to come in. It's always nice to hear you.
Ruhif's lead mod here, but don't tell him that.
Yeah. Shane, thank you once again for letting me use your server to have some fun, and I'll be back next week for more of the same.
Yeah, man. I mean, this is honestly the nicest I've ever seen you been, excluding the last time. This is crazy, especially with you and Winston, dude. So I mean, that's cool. I appreciate that.
There's reasons for everything. Don't worry. Peace out, guys.
You're gonna get him back.
Speak to you soon. Bye. Wow, guys, that was a fun one. Flat Earthers even got a concession from me about me being wrong about something because that's the intellectually honest thing to do. Doesn't mean that Witsit won a debate. It just means that I was wrong about something in a debate. And again, nothing wrong with that. And I've been doing a lot of studying on relativity, specifically talking a lot with not just people that you guys know, but people at Edinburgh University and other stuff. So it's a lot of new things to learn so that I can actually debunk Witsit's misunderstanding. Anyway, that was fun. I didn't realize that I've been going for over 3 hours and I'm pretty tired. So it's time to read super chats, which you guys have been incredibly generous once again. What's coming up on the channel is new episode of Flerfs Idiots is in production, but there's also bonus episodes that are going to be coming out, which are remakes of very early episodes. I'm going to start doing some polls as to which ones you guys want to see redone, but I'm going to be starting with episode 1. There's also going to be an educational talk with Professor Philip Bell and PhD Tony about relativity, which a bit of a change of pace. And of course, there's going to be more of this every week because, I hate myself. Icy Spin 199 says lobotomy fund advance, definitely needed, thank you. Mark Godin, $5 Canadian says good luck. Yeah, definitely need luck going into that place. because it's going to be lucky if my brain cells survive. Pronon 1990, been a member for 9 months, says, God, this is painful. I'm in the chat Discord. Yes, it's definitely painful. Sarah Jones, member for 4 months, says, Flat Earth pulls my IQ down at all times. Maybe it's Flat Earthers' IQ and not gravity after all. Who knew? Valkyrie Vision for $4.99 says, not enough weed to watch this Flerf, but I like Emma, so I'll stay. Emma's not here right now. She's in bed over there in the other room. But if you want to see Emma, go and watch the most recent episode of Flerfs Are Idiots. Stringer News 1 for $2. Flat Earthers are cognitive dissidents. It's cognitive dissidence. That's not what that means. Caucasian Sensation, member for 15 months, says, gotta lie, duck, dodge, and deflect to Flerf. Yeah. Hey, Caucasian Sensation, you wanted a rematch on the weed debate? Absolutely 100%. Hit me up. Email or DM somewhere, and we'll get that arranged. That should be fun. Probably get like MC Toon to moderate. Digital Demonic Davros, haven't seen you around these parts for a while. Hello. $2 Australian says, this guy is not a Flerf. No, that was most definitely a Poe. Albus for $5 Canadian says, the day you first present actual proof, your ridiculous pancake Earth, then and only then will you be able to criticize our experiments. Makes me laugh when they're always like, Cavendish isn't an experiment. Yes, it's exactly a fucking experiment. String News 1 for $2 says, damn it, NASA, pay the CGI bill on time. Yeah, CGI glitch there halfway through. Internet ran out. So, Pearly1408 for $5 says, the one Flerf has watched way too many of those movies where everything from space is made of completely unknown elements. Yeah. What unknown elements was he talking from? And you don't find, like gamma rays on the periodic table. Fuck's sake. Takos Kanos, for 7 months he's been a member, says, I see Witsit brought his fallacies again. Earthrise, member for 12 months, says, using science to debunk science is illogical. Well, it's the only way they're going to be able to do it, because they can't debunk it with fallacies. Jeffrey Hollenbeck for $5 says, Einstein used the experiment to update his model to fit the observed universe. So the opposite of what Flat Earth does. Witsit? Yeah, gone out of focus. Them saying that the Eddington experiment doesn't match what we should see is fucking ridiculous. Triple Crow K in the chat says, how does Witsit know more than every physicist that ever lived? Or were they just lying for centuries? They were obviously lying, and Witsit is the most intelligent person in the world. God, that's going to get clipped, isn't it? Yeah. How much do you think they're going to use me making a concession about being wrong about something as evidence the Earth is flat? Or some kind of victory? That'll be interesting. Glenn Collins for $2.99 says, for the brain damage incurred today, thank you very much. Much needed. Tokyok Yonosh for 1,024 huffs. Thank you. For your peg leg fund, get well soon. Thank you very much. String News 1, $2 says, a stopped clock is right twice a day. Yeah, twice more than Flat Earthers. String News 1 for $2. Flat Earthers don't need any help looking stupid. No, I don't need to write my scripts. They do it for me. RageBot for $5 Australian. How would gravity know when to change direction? You were right. This isn't enough facepalm protection. Yeah. Please stop suing me for damages incurred whilst watching my show. LB Things, Stuff and More became a member. Welcome to Scrappers. Thank you very much. Andreas Eldritch for 50 sex. I like all the sex. Says, so what if we have misunderstood gravity? How does it change the shape of Earth? It doesn't. And just because science doesn't have all the answers doesn't mean we can't measure and quantify gravity. Pen Pappy for you, $4.99, retracted their message, so thank you very much. And then gave another one, says, Britney Spears went on Instagram Live and was watching this live debate, Craig. She called Flat Earthers stupid. Her husband got her into this, she said. What? Britney Spears went on Instagram and was watching my debate? I doubt it. Albius, $5 Canadian says, OMG, the arrogance and pretense. Poor Witless, you were destroyed. Concede. They never make a concession. You see, I can do it, but Flat Earthers won't. Stringers one, $2. Thanks for playing, Austin. Game over, yeah. Oh, tell you what, me learning things is dangerous for Flat Earth. Stringer News 1 for $5 says, all maths are globe maths. There is no flat earth maths. Talking points are not maths. Flat earthers and maths, they just don't mix. As flat earthers said, maths kind of sucks. Dave Kircher, member for 4 months. Dave is one of my new favourite people in the world. It's not even science. Finally, a real debate after all these years. Really? Oh, with gin. That should be fun. Mark Grondin, $5 says, great job today. Keep it up. Thank you. I fully intend to do so. Almarge U for $5 says, is the drone inside the airplane needs to go fast on the front of the plane? And then for $2 says, outside the Earth, that is what you're seeing. And then says, for another $2, slow drone inside a 500-mile-an-hour plane. That's it, yeah. Drones are GPS locked. It's going to maintain its position relative to the ground, not the car it's on. Simple. Industrial Nerd for $5 says, if a fairy farts in the woods on the flat Earth and no one is there to hear it, does it still make a fart sound? Or is the fairy fart Flerf fallacy? Yeah. Replacing gravity with fairy farts does not debunk that we can measure it. Call it what you want. We can still measure a force that is proportional to the product of 2 or more masses and inversely proportional to the square of the distance between them. That's not a problem, and that's gravity. Matt Pack for $1.99 says, FTFE, you explained that education disproves ignorance. I do try. And then debunking flat Earth for $10. Thank you very much. Great job, FTFE. WITS has several fundamental misstandings of relativity and refuses to be open to learning why and how. It was big of you to be open to learning more. This is how science works. Well, yeah. How do I increase my knowledge if I don't learn and admit when I'm wrong? It's simple. Hey, Marikai, don't get me wrong. Dumpster fires aren't disappearing, and they're not really forced. They're more organic. But there's reasons behind the way that I'm acting at the moment. Very specific reasons. And I hope that you're still liking it. Anyway, the poll that I put up says, will this be the day Craig finally snaps? 60% of you thought I was gonna fucking... No. Not yet. Don't worry. I've got a few more years in me of talking to flat earthers before I finally snap. I had a good night tonight, guys, and I hope you have as well. Thank you very much for the support. You know, it means the world to me. Please absolutely incinerate the subscribe button and smash the like button. Just once, though. Don't do it multiple times. I'm your boy, FTFE, saying peace out. Wow. You remember when all YouTube videos started like that? It's me, your boy. Now the good ones start. Hey, I'm FTFE. Anyway, thanks for watching, guys. I love you all. And Nathan Bishop for $5 says, it's like 2 a.m. in the UK right now. You hold serious dedication to what you do. I know, and I got to get up in like 5 hours to get my kids to school. I love you, and remember, stupidity is not a right. Fight the flat Earth. Fight the flat. 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 Thank you guys for being here. It means the absolute world. Fight the flat. 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 Man, imagine if Britney Spears did watch me. Fight the flat. Fight the flat.